and then eventually we get excellent data in our YouTube stream. Good. And so now this can go all the way to the video monitor. All right, how's everybody doing? How are we doing? I ripped apart my synthesizer. I started to look at some of the stuff that Julian was kind of showing me. This is the thing that I'm building. And then I don't know if I'm gonna get him one of these or not. I guess he kind of wanted me to, so I might grab one. Yeah, genetics are fun. Yeah, fun. Fun is getting type 1 diabetes. Totally out of my own control. All right, in terms of projects we're working on, I got some stuff for the air raid siren. I got motor controllers for that, and the programmer for the motor controllers are AM32 motor controllers, and hopefully they're new enough in that whole thing that that I'm able to like program them and put in sine wave stuff, because that can apparently silence the motor, which could be kind of cool for an RC car project, even though I've already got enough of those 3-phase motors for this thing. Putting a better controller in here, well, that would be a bit of a hassle, because I've got the controller as like an integrated part. And I don't know if the AM32 stuff is great for RC cars. I think maybe it is. It might not have the reverse features that I like. I like a lot of reverse features because a lot of, for me, RC car driving is just putzing around on blacktop and like little suburban roads and just doing little spritzes around and then eventually running into something and having to unrun into something. So I kind of want features that help foster that, and that would be, you know, a robust reverse system. Hold on, I'm going to mute. That should hold to the outside a little bit more. What's up, Mahalo? How's it going? Yeah, it does. It does suck. It's all right. It's all right. AAPS has really sort of smoothed things out for me quite a bit. My averages and the deltas or whatever the hell statistical crap that's going on with diabetes when they check on you has been legendary as of late. So we're getting there. Weight is the next thing that I need to address. Of course, upon just merely mentioning that, Julian is already starting to invite me to mountain bike with him, even though my mountain bike is from 2008, I think. No, 2007. No, I think it's 2008. I think it's 2008. It needs a tune-up pretty bad. So I got some stuff in the mail. Among the motor controllers and things, I got these PCB standoffs that I thought were fascinating. These have little rare earth magnet cups on the bottom. The cup is, of course, focusing the magnetic energy so that you get a better magnetic loop, and it sticks a lot harder to flat surfaces. I know this from the tracking device government job that I had. But anyway, so I've got this big ass metal plate that I got from some such sale at a closing down machine shop. And, you know, I decided to buy these things without the plate because I got plenty of steel plates, right? This is pretty crazy. These hold really nicely. We might have to use these a lot in the future. I'm actually quite enamored with them because you can put them down and then expand it, slide in, hold up your circuit board. This is pretty well held, and this is a very heavy. Having type 1 gives you a lot of self-controlled discipline over, I'm a big fat guy. There's no self-discipline. I don't know, man. I certainly can't lecture people on having self-control and losing weight. I could maybe mention how utterly fucking difficult it is to do without a lot of externals, because even the type 1 diabetic, with all of his self-control, fails. So now that my glucose levels are like way more under control, I'm going to concentrate on reducing my diet. There was obviously from taking diet drugs. I'm on Ozempic, full disclosure, I'm not trying to hide it. On Ozempic, I've gotten that sort of legendary control. What the hell is that? Ugh, I gotta put feet on this thing. I've got legendary control over my glucose levels now, and we'll see if I can pivot that into weight loss. There have been studies out that have said you need to have exercise alongside of it. Those are also sometimes conductive. What are you talking about, lines and squares? I paid like 20 bucks for these. These are the rip-off ones. What you talk about, Willis? And they got these big rubbly things on the end that I could replace with silicone tube. This is metal. So the only plastic in it, okay, if that ring, this ring also I think is metal. So I don't think we have any pervasive plastic in here. I think I might be able to use this with hot air. But yeah, all I do is put it nearby. There's plastic in the magnet base, but by then everything should be cool. And you slide it into place and it just pinches. So I mean, technically I would probably be able to press down the circuit board against all 4 of these springs, but it's holding it pretty nicely in there. Oh yeah, we can burn the subs. You can see I tore everything out of the synthesizer. There's some things that need to happen. I need to build that filter and got a couple of other odds and ends that I need to kind of figure out for the synth. So I kind of tore everything out, and I'm going to take one of those power supply rails with me because I don't need to have 2 rails inside of that setup unless I go to one unit modules exclusively, but I'm not. You just seem like a big dude. That's what I've always gotten my whole life, is what everybody says, you know, you just seem like you're just a big guy. But that's still overweight. I still, the fat is not a different substance in me because I'm a big guy. It is still pervasive and unhealthy fat, so I need to get rid of it. There's no excuse. I don't like that. I don't like that excuse. You're just a big guy. No, I'm not. I'm 5'9". I am painfully average in every way. Painfully average. So yeah, these are cool. I think I'm going to use these a lot more. Genetics can be a bitch. There's so many other factors, like how you perceive hunger. You know, from person to person, the perception of hunger can be totally different, and that's a big factor in it. My belief is that there's a lot that isn't factored in weight loss. Yes, it does boil down to calorie in, calorie out, but that is like saying that sunlight is just photons, right? Like, there's so much more at play that people don't consider, and they use it as an excuse to be mean. And I don't like that. But they're not wrong. And in the same vein, they're also not wrong. It is able to be reduced down to calorie in, calorie out. But, you know, again, there's so much more behind it. So much more. But are there Wagyu humans? Supposedly sumo wrestlers, right? Because they have that, they have a specific diet, and they get frequent massages and sake. I don't know, maybe I should be doing that so that my fat goes into my muscles instead of into my midsection and stomach. My favorite is that weight doesn't necessarily have a ton to do with being in shape. I'm 5'10", I'm like 125 and very out of shape. That's interesting because, yeah, my goal weight is like 180, and I'm like, how can I even do that? I'm sitting here at, what is it, 260, I think. And I haven't been able to move the dial past 60. It was higher than that, but now we're mid 60 because I haven't been being vigilant about food intake. So I need to reduce that. The dog has gotten me to walk all over the place. It's like I'm not out of breath going up a hill. I can go up and down the stairs often a day. You know, I'm not totally out of shape. And you say, well, hopefully some of that weight is muscle. And I'm sure it is, because those muscles are required in order to move my dumpy ass back and forth. Basically, I'm doing squats, like thunder squats, all day, every day. And so I have G.I. Joe legs. If I flex my leg muscles, they are enormous. I used to swim, I used to bike. So all I need to do is, you know, maybe make them more prominent by losing the fat that's surrounding them. I was 120, 130 until 26. I went 210, what seemed like a month. Oh, finally in good shape in 180. That's good. Well, yeah. You know, keep it. don't fall back, because I got in shape at one point, and it took a huge concerted effort of a lot of biking and testosterone, external testosterone. I was able to actually, you know, get myself into a shape. It wasn't totally goal weight, but it was pretty good. And then I got fired from a job, and everything got a huge shakeup. And I came back to Philly and all that stuff. So I was not able to keep up with the regular exercise and all kinds of shit. I mean, that was like 15 years ago, so whatever. But yeah. And you are right. I do have a pretty powerful self-discipline. I just need to kind of work it in and get it to the point where I can take advantage of it, basically. Build habits over weeks and weeks. I don't think people who have never been a huge fat person really understand that. So these things are cool. I don't know where we're going to use them next. Maybe when we build one of these modules, we can utilize these guys because these will keep things nice and flat. I'm going to have to figure out maybe some feet to put under them. Is there dog hair in this? This thing is like new. Why is there dog hair? This is a USB cable tester. It's just a PCB that I happen to have nearby. But this, like, I mean, with the heavy plate under it, this thing ain't going nowhere. So it's pretty good. I'm pretty happy about this. What does a jumper do? S to G. Yeah, this will test all kinds of USB cables. Yeah, the thermal cam, it's got its own command. And it is basically to show where the heat's going when we're soldering. It's really useful for that, actually. And then when I power up electronics for the first time, which we may experience with Momo, you can see if stuff is getting unduly hot. You found me through Sid. Oh, that's cool. Sid is awesome. I don't know how Sid is not like the king of Twitch. Maybe I overestimate how popular modular synthesizers are. But yeah, Sid is super duper cool. Oh, we had thermals off on here. I guess I have to do that manually. I've built a lot of my shop stuff into Node-RED flows, and so I can control it on the Stream Deck here for things like hiding chat, bringing it back. That should have brought it back. Hidden, visible. I should have something come up on screen. If I mute my there's a little logo. You may or may not be catch the logo in the corner when I mute. And some of them are just petulant. Like if somebody says, "Why are stream starting soon?" it will make it enormous during the stream starting soon. I am not above being petulant. Thermals. Boom. Okay, yeah, that one's broken. All right, thermal, frame, thermal. That's over here, and I just do that. There we go. There's thermals back. It's a Lepton 3.1 thermal image sensor in a group gets thermal webcam module that we then 3D printed a little case around, and that's basically within biting distance of my face, so that things I see are what you see. No, starting soon is not the issue. That's just what we're doing right now because I'm not looking at Momo right now. This is the result. You're looking at the result of the Eurorack stream. You did this to me, chat. This is your fault. Actually, no. Julian and I went over the synthesizer last stream, and he had a couple tips, and he had some rearrangement tips, and also some module tips. There's some stuff that I still need to build and put together and order. And then I think I'll have a at least fledgling modular synthesizer setup. So I definitely want to build this crazy fancy filter soon. I don't know if the pick and place, I don't know if we'll be able to finish the pick and place by the time I want to build this though. Why does it say stream starts soon? Why didn't that trigger it? Curious. Why didn't that trigger it? I want to build this thing, man. This thing is really cool. But as you can see here, there's a lot of little doodads on it. Look at all them doodads. It's a lot of doodads. And it's fairly dense. And I think I need to get custom spaced headers. I hate it when they don't use 0.1 inch headers. I mean, obviously, this module is 4 circuit boards and a front panel. So they didn't have room for a lot of stuff on each layer. So they decided to attach their layers using specialty parts that I don't stock. So I'm gonna have to figure out what parts they like and buy them. I hate that so much, having to buy custom weird parts, because some module maker has decided that they would use things that are outside of the purview of your average. Actually, I think these are 0.1. If these are 0.1, that's helpful. I still need to get dual row headers at some point. You don't need dual row headers. I guess I could just do my single row headers. I don't know if I have compatible female headers for that, so maybe I'll use the round pin ones. Maybe that'll work out. This is some dense stuff. This is like something I would make. Oh yeah, it is like something I would make. How much like something I would make is it? Well, they're not using curved traces. with all kinds of different weird radiuses on them. They're using what is recently my favorite color circuit board. I do like the yellow. I think it's a very fun color to make a circuit board. And it's got a nice contrast between the sort of yellow-green and the yellow-yellow. I don't know, are they going to Seed Studio for these? It kind of feels like it with how blurry these are. When you get to the smaller text, Seed Studio starts to look blurry on the camera. I think it's just because their silk screen can't really get that small. It does look like, man, that looks familiar, huh? I wonder, it could just be a machine at a different company that has a similar process. They have a little like bottom and top thing too. Oh, that's cute. Very cute. This is the, who's this? 3-tom modular synthesizers, MS-22 dual VCF, number 520. I bought this from Modular Addict. It uses a lot of fairly basic parts. We actually do have, I think, whatever that is in stock, I think. I know we have these. If these are transistors, there may be some specialty chips. I got to look into it. There's a lot going on this board. There's a lot. Too much. So I'll have to get all my ducks in a row for this. What I wanted to do, the vision that I had for the MS-22, is that all of this stuff is like laid out really nicely, right? There's no components on this side, except for the headers and the hand solder stuff. But on this side, we've got all these surface mount components in like a grid layout. What I wanted to do is finish that pick and place, which I've got. Hold on, let me go grab it. Oh man, it's on a heavy base. I wanted to finish the pick and place, which requires us to make some physical stuff. We need to make some air stuff so that I can properly pick parts up. And of course, this isn't really parallel to the desk, so I need like an adjustment because this is, there's a little bit of, it's a big Bowman arm. There's a lot of weight on it. But the point of it is that with lesser springs, this would be a very light throw and it would stay parallel to the desk. So I may reinvent how to do this because this is certainly not staying parallel to the desk. It's possible that if I use nylon rollers, that'll keep it parallel, and then I could maybe have an adjustment by putting shims in it or something. Just a thought. But anyway, figure out what's going on here. And what I'll have is a little spin control on this head, so I can move it into place, lower it, pick up a part with a vacuum, twist the part, put it in place, right? I want to do that with all the parts on the board, then move the board to a hot plate and get a really good shot of the solder flowing over all the components. Because if you put something down and it's misaligned just a little bit, there is so much surface tension from the solder, from the lead and the silver, so much surface tension that it pulls evenly on all of the pins and your parts can arrange themselves into place. So if you have misaligned resistors and stuff, as long as they're touching the two pads, they'll shift into position. And I want to get that shot where the solder flows over the whole board all at once. It's a good thing to do with like a big toaster oven that has a big glass window, which I have, which was sent in by a good friend, a very, very good friend. And so if we take over the temperature control of that toaster, we could turn it into a soldering toaster. I still haven't desecrated it. It can still actually toast food. So I don't know if I want to do that or not. So doing the open hot plate is the alternative. And so this would be moved to an extremely hot surface somehow without burning myself. I'm not sure, maybe sliding it in because you don't want to like drop it. You don't want to do like that because then things will choop. So you gotta get real close to your hot plate without burning yourself and just drop it on. I don't know how I can do that. Can't do it with these. These won't work on that. I can't use these on the hot plate because I got an aluminum surface, right? And magnets hate heat. So putting it into something like this and then building it up with the pick and place, I'd have to be able to easily and cleanly remove. I guess that's okay. That kind of works. So that could work. And then somehow, without touching the hot plate, no, I'd burn myself. I'd burn myself pretty quickly. I think the best way to do it would be to go like this and then use a pair of tweezers or something to sneak it on. And then presumably from there you get good contact. I mean, you could start with the thing off and captain tape this down to the hot plate. Yeah, that was it. Yeah, I was just getting to that. That could be the other way to do it. At the technical job I had at the FBI, they also had a soldering oven that had one of those metal. It was like a metal conveyor belt kind of thing. It's like what they toast bagels with. When you put the bagel in the toasting machine and it goes down that conveyor belt, like with the metal mesh conveyor belt. They had an oven that was that, and so they move it in. You have it solder in full view of a big glass window, and then it moves back out on the conveyor belt. It was pretty good. It made some pretty clean circuit boards. I was basically given the go-ahead to sneak in on a weekend, and I could use the pick and place and the oven to make a bunch of circuit boards that I then put on a theater globe that was full of LEDs, and we hung it on the main gun of the USS New Jersey for a party. Sailors are very uptight. They have sailors that are stationed on it, even though that boat is technically a museum. I guess they're there to make sure nobody steals the USS New Jersey and like takes on the US military with their old equipment. But they were very uptight, those guys. There was not a chuckle in them. I couldn't find it. My personality clashes with people like that. Very serious people who don't laugh. It's bad. I'm always trying to get a rise out of people. Or not a rise, a laugh out of people. I need levity, or else I start to get real self-conscious. All right, let's get this out of the way. We got to do some like system checkups today, because Momo met a very predictable end. Momo ran into the MOSFET conundrum, which is that MOSFETs are really good at switching heavy loads, but they're also very sensitive. They are self-conscious. They just don't like to be alive. And so if you tickle your fets wrong, they blow up. So what I'm going to try to do... What's up, Gomania? What I'm trying to do is get Momo over onto the bench. The blade is sitting on top of it right now. And we're going to take a little bit of time to look around. You need to start pinging the Discord when you stream. I always thought that was annoying, but did you know? I don't ping. I don't do that. I hate pings. Just the same thing with the insulin pump. When I hear a beeping noise, I want to attack the beeper and kill it. Because my insulin pump beeps at me and I have to pay full attention. So pings on Discord, I try to avoid. I don't like sending out pings for pretty much anything. I kind of heavily censor that. Why is my user image censored on these? So we do have an announcement channel, and if you want, the announcement channel can send you something. But other than that, I don't really stress that. So yeah, if you pay attention to the announcement channel, you'll get a notification for when I go live, or have Twitch ping you. You're in control of that setting. Innovative modulation matrix and one of the highest function to HP ratios in the land of Eurorack. This module was inspired by many pleasant chats with tech journalist Steve O'Hare. It's kind of cool. There's a big how-to for this thing. You can subscribe to the channel. I haven't done it, so I wasn't confident in telling them to do that. But yeah, if you would like to, you can subscribe to that channel. All right, let's get started. We got enough work to do to take up an entire stream, right? Well, maybe not. If this thing works perfectly, we'll figure out something else to do. I got plenty of stuff. How's it going, everybody? So recently, a friend of mine was poking around with his fully functional and happy robot vacuum robot vacuum cleaner named Momo. Sorry, I keep calling... I'm going to call it a vacuum cleaner throughout this entire stream without my consent. I don't mean to. My brain doesn't work. Anyway, Momo is a robot lawnmower with a bunch of custom stuff as well as a custom brain. I guess this was a model of robot lawnmower. The pause was because my brain said vacuum. This is a model of robot lawnmower that then got a takeover, a DIY takeover. So it's got, I think, several Raspberry Pis. It has a sprinkling of Pico Pis in it. The cheap RP2040 microcontroller that functions really well. It's a really good microcontroller. Yeah, Raspberry Pi, Pico Pi, custom stuff all over the place. My friend was happily watching it do its job when it locked up or something and started sizzling, and then he decided to fix it, and he fixed it and it worked, but then he decided to put heat sinks on it. MOSFETs are fickle mistresses, and so the sizzling came back in the form of burnt MOSFETs. It turns out whoever designed the control board for this DIY custom, the open hardware robot lawnmower. If I had, listen, if I was more popular, if I had 200 people here regularly, actually, you make it happen. The one downstairs. Come on, Satan, give me a lot of viewers. Anyway, so it looks like I'm just talking to my dick. Anyway, robot lawnmower. It is a DIY robot lawnmower. I'm totally unfamiliar with it. I have intentionally gotten no information from my friend. The thing about the design, he's explained a couple things to me, and one of the things he explained is that whoever designed the motor controllers designed them tightly in spec. Coincidentally, they're Germans. Anyway, they put the specs so tightly that when something wrong happens with the motor, it goes, I'm out of my, and then it's dead. MOSFETs and motor controller boards are notoriously janky. Remember the time, none of you are from it. Maybe Mahalo might remember the time we took a bunch of my green Outrunner motors from a big drone that I wanted to make and then crashed. And we tried to hook them up to the old motor controllers that are these like Afrotech, they're ancient, right? Old Hobby King stuff. And we were just churning through these motor controllers because you'd hook one up and it would work and then it would go, and then die. Just because the fets are just that sensitive. So, very frustrating. Fast forward 10 years. We're now in 2026. Did you guys know that that's what year it is? We've got better motor controllers. We've got stuff that functions a lot better than that. So what my friend has done is he has ordered 3 new motor controls, 3 motors, right? You got 2 geared motors for the wheels, and then you have, I believe it's still geared, I'm not sure, you have a blade motor. So you've got this light little blade with these little, like, almost just the, like these sitting on the end, the old 1980s, like doing crack razor blades. You practically have these sitting on the end of a little flywheel that's cutting the grass. 7-stream streak. That's pretty good. When Roboz came up with the 180 for me streak, I decided that I might turn off that feature and never again purport to know how often I watch Robert's stream. It's sick. It was disgusting. I didn't want to share that. I've shared it with you guys several times against my own will. Want to buy views? Yeah, no, listen, if you say stuff like that jokingly on Gonad stream, the auto model pop you because he's set it up to be so extensive to kill those things instantly. I like having them come up because it's funny for me to ban these bots. But yeah, and by the way, there have been people who personal friends of mine who have said, "Hey, I think I'm banned on your stream. Can you unban me?" No, because I pull up your name and it said you weren't banned. So there's some Twitch chicanery going on there. If you guys are like, God forbid I lose a viewer, right? If anybody has been banned and they're still banned, like just let me know, jump in Discord or something like that, and I'll unban you. How about 7 push-ups for the streak? How about you go fuck yourself? All right, anyway, Momo, the robot vacuum cleaner, lawnmower. Shit. Let's get that over here and put it on my stool. All my troll accounts are banned. Listen, if you get banned from Discord too, that's your problem then. That's no longer my problem. All right, this guy is just to prop up stuff, so we're gonna take Momo, we're gonna put it up on there. I'm not sure whether or not I want to remove Momo's little cowboy wheels. Momo's little cowboy wheels. I also don't know what gender to refer to Momo as. We want to kind of respect the bots around here, you know? Well, respect this bot, but not the other ones. I had to take a hose to the bottom of Momo because Momo was full of ancient and caked on grass. There's even bird poop on top of Momo. And I'm missing one of the lock washers, so this will get new hardware. This little blade locker. See, this is just it's just like a plastic. This is a plastic flywheel with these little like razor blades on the sides. These are not incredibly sharp. They're not incredibly sharp, but you know, not having them on there is nice. So let's get. I need to somehow contain these 3 little screws. I'll just put them over here for now. What we're trying to get at are the system boards on Momo. The system boards on Momo, where the motor controllers are. We need to make sure that when a new motor controller goes back into this thing, it doesn't blow it up. So I have not gotten any info. Well, my friend sent me a whole Google Doc that I didn't look at, right? I have not learned any new information about Momo because I kind of want to take you guys with me on this journey. But also, our job is not all that complicated. All I need to do is power this thing up, possibly from my bench supply, and see if it's trying to communicate properly to all of its buddies. This thing uses, I believe, CAN bus to communicate with stuff. And so the motor controllers that are going in, the new ones, will just use CAN bus. We can make a little prototyping board that will adapt one thing to the other. And supposedly it should all be configurable and sort of, you know, compatible once we make that pinout board. So this is Momo. Momo has a little cowboy hat. Momo's a cowboy. And so my friend has dropped this off with me to be in the best hands to get electrically repaired after a small explosion. This is a very common thing if you are the purveyor of the soldering arts. You will get things like this every now and then, which are a treat. And every now and then you will get a computer power supply from somebody. Hey, I upgraded my power supply. Do you want the old one? No. Okay, cool. I'm dropping it off later today. Like, oh, okay. Another computer power supply. All right, so we're going to remove the hood. And I guess where all the old electronics went. Look at this. There's like a little control board in here. And it's got a Pico Pi of its own. Crazy. I have no idea what the hell's going on with this whole thing. This whole thing is baffling to me. What year of manufacture is Momo? I do not know. Oh, there's still grass in here. And like bugs. Ooh, look at all those bugs. There was a seal on this, so I didn't feel too bad taking a hose to the undercarriage. I made sure to only get the undercarriage wet because there's rubber seals on everything, so hopefully we don't see anything weird. Everybody in the class, say hello to Momo. Yeah, that's right. What is this text over here? There's a giant stop button on this. It's great. Stop! Okay, looking at Momo. Sorry, Momo, you came into my house under my hospitality, and I almost immediately strip you. The flux I'm not concerned with. The soldering looks perfectly fine for a Pico Pi. Pico Pi has these little Among Us shaped pins, and those little Among Us shaped pins, I forget what there's a term for that in circuit board design, but what that is for, where is a Pico Pi? I don't think I have a bare Pico Pi here. Bear with me. How do you guys notify somebody that you're under hostage from a hostile wild animal? Bear with me. So these little Among Us pins are designed to have flat pads on another PCB. The only problem with designing stuff like that is that you've of course locked out all of this wonderful stuff on the underside of the board. You can't access any of that anymore. But you get to solder it very cleanly and very mechanically stably to another board. Holy hell, there was a lot of flux in that solder. Whoever built that, damn. Castellations, that's the word, thank you. It's not, listen, I have a moldy brain. My brain is moldy, it's full of mold, and sometimes the axons need a little brushing off so I can remember things. And then someone gives you randomly gives you a car chair. Life is a mystery. I had to request the car chair, and it has been nothing but a burden. Let me tell you, The shop floor did not have room for that, and now it even less has room for that. But we got to work on that soon. I'm fixing to build like a side pod with all of the controls on it, so all the switches and buttons and stuff, and then we can look at getting the joysticks mounted and all that stuff. But we got to work on that CAN bus thing. I think I want to build the side pod because it's going to happen anyway. What's up, Madam? You properly stretching your legs in the YouTube chat, the empty YouTube chat. Open Mower UI board, CC by NA or whatever, SA 4.0. So Clemens Elefine, I suppose, is the purveyor of this project. They've probably done an excellent job putting all of this together and open sourcing and everything. I always, listen, we can be a little bit critical of board designs and stuff here. We can be a little bit kind of mean because we're like movie reviewers. We don't have to be nice about anything, but the people who share their projects open source, and especially something like this, I have nothing but love for those people. They make amazing stuff, and sometimes they're not great at what they do, but they still open it up for the whole of the internet to come in and look at what they've done and go, hey, that's wrong, which takes chutzpah. That takes a lot more than I think we like to give credit for. So credit where credit is due. This is an amazing project, and it probably works great. We will be criticizing the motor controllers a little bit, but what is it? It's a little, oh, that's a rain sensor. That should probably get a good clean off. It looks like it's got a little bit of a half cell stuff going on up here. This thing has a rain sensor on the outside. That's cute. It's got a little rain logo and 2 terminals. Here, look. Cute as hell. This thing is old and it's gone through its paces. We're gonna try to get a year from it. But look at that, it's a little cup. It's a little ICUP, and it catches the water and says, hey, there's like a capacitance change. I mean, you could do this, or you could do a sheet of glass with an internal bounce sensor. That's what my car does. We can see age from the moldings. NHA, BPS, NHABS, so ABS, but NH, I don't know what that means. 1958005. They're making it hard to. 21. So this is from 2021. The plastic is anyway. It could have been molded years before it was actually put into a product and sold, but so let's put the top cover of Momo. I would love to put the top cover of Momo somewhere so that Momo's little face would be visible everywhere. Look at these googly eyes, man. They've seen things. These have seen things. There's 2 types of movie reviews: people who want to be a tastemaker and people who want to write true critical theory 3-hour essays on YouTube. My favorite is when it's basically the genre of video. I was looking into something innocuous, and then I became an investigative journalist and ruined several careers with my video. H-Bomber Guy is famous for having several of those on his channel, but Folding Ideas has done a couple, and there's a few more out there that have done these unintentional, they've been forced into making a giant video essay about a topic that they only sort of just brushed up against that was way deeper than they thought. I love that genre. It's so awesome. It's like, don't look at the title, don't look at the bar, don't look at how long the video bar is. We're done with the subject, and here's 5 hours about something else now that I barely brushed into while looking into something else. That whole plagiarism kerfuffle was quite fun. Okay, this is a lot. Let's see if we can bring Momo's body over to the desk. We're not gonna have a lot of room. Not gonna have a lot of room for Momo, but we do need to get Momo on the desk, and I'm debating whether or not I want to remove Momo's wheels. If I can get a little bit more room with the electronics. It doesn't look like I can. It's basically a 2-motor caster robot, a very typical design for student robotics and stuff like that, and it's effective. You've got 2 geared motors and then 2 swiveling casters on the front. You could do 1 swiveling caster, but this is more stable and keeps you from changing the distance. So with a 3-wheel system, you can kind of collapse on one side, and so that would make your blade get closer to the stuff. This seems a little wonky. Oh, is this a... Oh, blade height. Wow, okay. Whoa. Oh, and inside there's a Lynx motor, huh? You can see Lynx in there. Okay, well, learn something new every day. This is very greasy. I'm putting it back. You go back in there until you're tight. So that's your height, and it's adjustable from the top from this little keyway right here. The people make games Roblox vid. You mean oh, you're not talking, that's a different channel? I've not seen it. Yeah, H-Bomber did a big Roblox that looked into the career of Tommy Tallarico. I gotta see, I bet Sark knows who that is. I don't get to personally talk to any of these people that I mention online, by the way. I'm not that popular. I just know people that know people. So, Momo. We got spiky wheels to move us around the grass. We have casters on the front. There's some kind of a sensor on the caster that I'm not sure exactly what that is. I don't know if we have angle sensors on the casters. Oh, we have height sensors on the casters. So these fall down. They've got a rubber, like a rubber grommet. It's like a shifter rubber underneath it to keep, you know, wet grass from getting into the main body. And you can see it's done a good job. There's not wet grass inside of the body of this thing. I have absolutely no idea where the batteries are. They're probably in between the two. That's like a handle. I don't know where the batteries are. There's probably a little bit of space between decks here. And we've got big geared motor assemblies for the two wheels. Yeah, so a bunch of wiring that's been taken up. We got our GPS antenna, which is isolated and out away from everything else. I don't know if this may also do Wi-Fi, I'm not sure. Over here, we have the main open source controller board where there are 3 motor controllers. So you can see 3 just sort of Aztec style ancient ruins. These were scanned by a drone using ultrasound, and we can just see them in the layout a little bit. Now, they're you know, 3 missing headers for motor controllers. It will be easy enough for us to figure out what the pinout is, as long as these things are all 0.1 inch spaced, which, knowing the designers, I don't know personally the designer, I just know they're German. And they seem, I don't know if they're going to use standard pin spacing. It seems like they do over in this corner, but this looks like a non-standard space here. I'm looking at the spacing between the things. So it might be a little bit more annoying than I thought to build an adapter board. We can still do it though. And we've got, one of the good things about this is we've got so much room. Why is this not focusing? There we go. We have so much room inside of here to play with. We need to figure out what connections are the battery. Everybody's labeled power, motor. What? Yeah, lots of options on this thing. We're going to have to take a close look at some of the power pieces of the board. There have been some repairs. This fills me with trepidation. Something's gone on over here, and we need to figure out what the deal is. It may be that my friend just did not have... It's Big John, if you guys are wondering. It's Big John in chat. We're not going to criticize anything Big John did here because he got this thing running and working for months before it blew up, right? So he did a great job. But anyway, this scares me, and I can do better repair than this. So we may swap in a 7805. Maybe if he were to pop into chat, I could get a recommendation from him. If he is hell-bent on using whatever this is, we can put in a surface mount mod and make it a little less, you know, this isn't making connection right now. It's actually broken. I've just found out by touching it. You really shouldn't, you know, but it's under vibration. And so if you have a big moment arm like that with solder that might be cold soldered because you can't get enough heat into the tab, then you're cruising for a bruising. That may have been one of the things that led to the demise of Momo. We don't know. We can probably fully remove this circuit board and take a look at it. Supposedly, without the motor controllers in here, this runs. I don't need it to connect. I don't need it to get to any further diagnostics. All I need this Pi to do is to try to talk to its constituent parts with the right voltages and the right languages. So we're gonna check that over and then do our minor repairs. If we see good CAN bus coming into this thing, and it doesn't need to be good CAN bus, it can just be diagnostic CAN bus of this thing saying, hey, is anybody out there? That's enough for me to say, okay, let's go ahead and put new off-brand motor controllers on this thing. explosion after months could be flyback on a MOSFET. That's also possible too. I don't know what these, we have some of these motor controllers. We can take a look at them and try to get to know them a little bit to see what blew it up. And then hopefully the controllers that are going in are probably going to be a lot more robust. We just need to make sure that the blowing up of the MOSFETs didn't cascade down the line and kill anybody else. That's our job. So this is very hardware. I mean, my friend was like, are you sure you don't want me to like put in your Wi-Fi stuff? And I was like, nope, we're taking a much lower level look at everything. We need to look at voltages and like individual ones and zeros just to make sure that everybody is doing their job initially, and then the higher level problems from there can be diagnosed. The GPS is like a $100 GPS. I have that in the little bin that my friend gave me. We're going to be careful. We're going to take it a piece at a time. This thing is like leaving marks on me. All right. So take a look at what we got in terms of battery on this thing so that we know which lines are live, which ones are making sparks. Take my little multimeter. Why don't you sit right there, multimeter? We're going to take a little gander at what you got going on down here. Man, I gotta watch Deadwood if I'm gonna work on this. Did you guys know that cowboys curse? Apparently that's a thing they do. They curse a lot. It's crazy. All right, so all these different wires, all these squares make a circle. That is a little bit tight. I don't like that. I guess the sensors, how are we treating those? Let's get the label maker over here just so I know who's plugged into where. I'm going to get the label maker and I'm going to label out all these and unplug them so we can get, well, let's just look over here first. Luckily, this is, the multimeter is what's called high Z. High Z means that it doesn't have any resistance to it. So when we hook it up like this, the battery, as long as it's below 3000 volts, doesn't have any chances of shredding my connections. I'm not finding it, at least in relation to the white wire. Oh, there we go. 24 volts. So we're in a 24 volt system, which I was warned about. Let's see, did we use the right headers? This is an open source project, so we got to be careful about that. Sometimes the designers aren't using the proper protocol for this sort of thing. We are. Okay, so it's a Molex like knockoff, carrying 24 volts on a 18 gauge wire, but the completely shrouded connector is the one with power on it. This one does not have power on it, so it can be the other connector that has sort of the pin in it. The pin in it. Pin in it. Okay, these are the motor connectors, so let's get those up and at them. I don't really, oh my God, it's a full ATX connector. What? Molex sells these to mortals? That is a whole goddamn ATX connector. Let's go get a power supply and plug it into this thing and see what happens. One of the power supplies that my friends have left me with. Hey, you want a power supply? No. Okay, I dropped it off. So by virtue of where these things are located, we can probably find them again. Also, I have it on video just in case. Here, let's lift the light here until we can get the circuit board out. I just want to get this main board out so that we can inspect it. We might be able to hit it with 24 volts, like a virtual battery, and just see it kind of come to life. But the first thing I want to do is look at a couple of the little power supply junctions here and just get a look at the board, both sides of the board, make sure, you know, around the LED, around whatever the hell this stuff is, why there's a missing capacitor, take a look at the modifications down here and see if we need to do a little bit of rework on our end. What does this wire go to? Well, hopefully nothing permanent. Okay, so we're just going to go plug for plug, but I think I really should, yeah, I should label these. Okay, so either the label maker or actually this is a good opportunity for me to use my, oh, but those are going to move around. Those are going to move around. We need to be able to identify where these cables are going again because I don't know what I'm doing. So I think what I want to do is get my number tape and just give these little number wangs so I know who's where. So this stuff, I think I stole this from the government, but this stuff is just literally 0 through whatever, and you Just peel it off like this, and you can label stuff. These are very strictly temporary. They're not great at sticking to things, but what I like to do with them is take a connection and just make a little number wrap around the end. So that one's 0, and then I can take another 0, put that here. These will move around. They're not great at sticking around, so you just and they don't really, well, they leave a little bit of a residue if you're not careful, but yeah. Maybe it was previously an RC mower. It is now a robotic mower. All right, this one will be 1. Tug that the wrong way. Yeah, Momo is a robotic mower with an open source mowing project. It's called Open Mower. And we'll be taking a look at Open Mower in just a second here. So that's 0. This one's 1. Putting these aside. We're just making room for an ant to hide. Nature's candy in my hand, or can, or pie. Do 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 do. Yeah, your peaches, peaches for me. Yeah, peaches, peaches for free. Look out! Let's go a little higher up on that so it's not as jank. What the? Oh my God! This is where you would hear. Code Rushed is raiding with a party of 4. I have holdups about the air raid siren because I got the motor controllers for the air raid siren. They could actually be put in here. They're not CAN bus compatible, but Code Rush with a party of 4. Accompanying this, I'm thinking about building an air raid siren, and the air raid siren would make it so that if somebody raids into my channel, it has this whole hullabaloo going on. But the problem with that is that I think I would probably scare everyone in the house and my dog, which makes it sound cooler in my mind, but maybe not so cool for everyone else involved. If it's going to be loud and it's going to hurt my ears, I'm not going to do it. But I'll finish the build at the very least, just so we know what it is. So yeah, what we're doing is we're taking apart a robot lawnmower. I keep saying vacuum cleaner, and that's not going to change. I'm very sorry to all of my friends who have changed pronouns. I apologize profusely for future bothers. Inability to learn new information and roll with it. It's not for lack of trying, and I'm not being mean. I am just dumb. And this is proof. This is proof of that. That I have this robot lawnmower, and I've never worked on a robot vacuum cleaner, and I still call this thing a vacuum cleaner. All right, now 5, I'm going to put a little label down on the board for row 5, so I know where 5 and 6 go, even though they are different plugs, and they probably can't reach anywhere else, just in case, just so I know. So that's where 5 and 6 go. So 5, take a little bit. So I'm just making these temporary signal flags so that I know what's what. What we've done in the past is used markers to mark, but these will come off without leaving a mark behind, so. Leaving a marky mark in the funky bunch. All right, number 6. Give me this. It has a cute little speaker. Yeah, I think it talks. I don't know if it talks like a cowboy, though. That's something that could be improved. Howdy, partner. Need me to mow some? I reckon I could do that. I do not see any more cables. I think we might be good to get this thing out of here and then take a closer look. Maybe slowing down the spin would make it quieter. If I just flick the thing, it makes a very low kind of thing. Very, very low pitch. So it's possible that if we do have a good motor controller on it, it won't make a lot of noise. That's the hope anyway. Where's my... Okay. This is bad. This is real bad. I'm not supposed to be missing these. These are my good screwdrivers, my Worths. Worthy? No, what is it? It's not Worthy Kids. It's Wera. These are my Wera screwdrivers, and they're very special, and they're very nice. They're not terribly expensive. They're just good screwdrivers to have for electronics. They got a good length, good handle, all that stuff. I'm missing the large Phillips head, which is not good because whenever I remove one of those screwdrivers, I'm very careful to make sure to get them back to their spot. Everything in a place and a place for everything is something that helps ADHD riddled oh bother keep his head on straight when he's working on projects. Found it. I have a set of Ware hex drivers. They're damn good. I've been thinking about getting the hexes. I've been thinking about that. I haven't done it, but it might be a good... I don't know. I haven't needed them. I have a set of dumpy hex keys over here. If I move shop one day, I might make room for all of my T-handled bits, and then maybe I'll want to get one of the Ware backings for the screwdrivers so I can put them in like their own little plastic thing. That might be good. What all is holding this in? Is it only 2 screws? There's more to... Oh, I see. So the board is pinched at the back, and then, oh my God. Okay, USB here. USB here. Okay. It's 2 screws on the front, and then these 2 are holding the backs. And then we get this giant battery pack. Holy crap. That's a big battery. And a lot of wires. A lot of wires. We've got a miniature RF connector here for this one. And then this runs to a different antenna at the front, huh? I wonder what that is. Blocks? Open Mower GPS base version 0.9. Okay. So I guess the Wi-Fi antenna out the back. And then there's a fan spot and a Raspberry Pi that's got some gloop on it. That spot for a tiny little fan. Isn't that cute? Woohoo! Well, that's something to look at. All right, so open mower board we are going to place very carefully. It's right there. This thing, we're going to take Momo and we're going to put him all the way over here on the stool so that Momo can think about healing. Oh. Okay. All right, so let's take a look at this open mower main board. This is, I believe, my friend tried to contact me looking for help with his open mower, and then he figured it all out without me, which is very nice to hear. I like it when my friends figure stuff out. But yeah, this is, where's this? I put the DVD case on the DVD player. I have a system. Yeah, it's having like little systems to do stuff is really important. All right, so I got a lot of grass clippings on the bench right now. Hold on, I gotta brush this all off. Whew, a lot of stuff. Okay, so we've got 2 sand discs sitting 6 feet apart. I work with hex screws enough that the driver, which is designed to make it harder to strip them out, was worth the purchase. I see. Well, so I use the T-handled bits, and they fit very nicely. That's configured for 5 volts. That's a chip that I have no idea what it does. Capacitors look okay. This one looks a little weird. I think that's okay, though. Wouldn't we see scorching around it? This, like, it's bowed up a little bit, though. There's like a little... It's a little crust, but I don't think that's dead. It looks like it's still... Hold on. Get up in there. Yeah, I don't see an opening. I'm a little wary of it, though. Oh. Oh. Oh, what happened to you? Oh, you poor thing. Well, it's open source, so we can look it up, but that looks like a dead chip. I mean, it might still work. It doesn't look too... no, look at the pins on the side. So we're looking at my buddy's open mower, robot mower. Don't say vacuum cleaner, bother. Little bit of something going on over here. So that chip is gone. We're gonna have to get a new one. Buy a new chip. Do we need both of these caps? Not sure. This one is definitely not in. JP4 had something going on and now doesn't have something going on. Momo pooped the yard. Yeah, pretty much. Why is, so there's stuff, it looked like stuff was attached, but now it's not. And it looks like JP5 is already bridged there and JP4 is bridged there. So I don't know, maybe this is just a solder paste snafu. But that, I don't know if that is indicative of this thing exploding, because this is what's called a QFN. It's a quad flat no lead. No lead means that the edges of the epoxy substrate have pins on them, and basically the pin is, you know, it's kind of like this, where it goes at 90 degrees and wraps under a little bit. So it's on the side of the chip and then it wraps under just a little bit, and it allows it to make this big blob of solder happen. Something happened with this guy here. It may have overheated and popped and cracked the outside epoxy. Something mechanical could have come down here and grabbed it and pinched that, but these look like they are cold solder joints. So it may be that this got so hot that some kind of like an impurity in the epoxy expanded and blew up. By using this device, are you Captain Hook? More like private Hook. Yeah, I don't think I've made captain yet. There would be a big celebration. I'm not in the military, by the way. I'm only, what do you call it again? What's it called? Stealing? No, it's, darn it, what is it when you impersonate a military member? Anyway, so yeah, it looks like something, this may have heated up and blown up. I mean, it is looking a little weird. Stolen valor, there we go. I'm only stealing valor, you know? I'm not actually a member of the military. So C10 might not have been populated. It looks like it's parallel with this other one, so maybe they just decided, there's not enough noise that we need both of them. This doesn't seem like it heated up and a capacitor fell off. But over here, I'm seeing signs of heat. There's a little discoloration on the leads, which might just be like an excess of flux. As we're seeing, this board never got like a final wash. It's not a professional board, this is open source. But this may have heated up by the indication of cold solder joints on one side of the chip and the missing epoxy enclosure. That means we're probably going to need another one of these, and since this is open source, we will have to dive into the GitHub. The GitHub is over here. Clemens Elfine Open Mower. They've got multiple, wow, okay. They're a busy bee. Some people are busy bees. Kind of like applied science. I open up applied sciences video today and I'm like, I like building my little audio circuits. I built a little audio circuit that's not mine. And he's like, that's nice, but in order to fix the side fumbling problem from my millimeter wave laser that I borrowed from a friend, I'm going to have to invent new math. And I'm like, what? Huh? I feel like I'm playing blocks compared to what applied science is doing out there. It's crazy. Let's keep looking for damage. We're going to keep looking for damage. I may need to remove the Raspberry Pi and take a look inside. Well, U3, I bet, feels useless. Because you have something to do with switch 1's just gone. J22, looking okay. Everybody's looking okay so far. You know, this is likely stencil soldered. It's looking pretty good. This could use a little... Ooh, why is it so loose? Is this like a... Oh, it's some kind of a selector, but man, that is... Wow. That is... Who did this? Who did this? RPi force power. No. This is, don't do this. Good Lord, that needs some epoxy on it or something. The color change on C12. You see how fast it is for me to find C12? I haven't found it yet, but I'm saying, like, compared to the modular synthesizer circuits where you find it hard to find a specific value, you could see right there what I was doing. I was going through and I said, well, C12, it's an old comment, R5, R4, C25, C26, C20, we're getting closer to 12, 13, 14, 12. I was reading it upside down. I thought it was C21. C12, discoloration. There's a little bit of discoloration on it. I wouldn't say it's concrete evidence of anything, but we are dealing with an area where we suspect things overheated when everybody went haywire. So it's possible that that is due to heat. Oh, you don't need to tell me where it is. I'm using that in order to teach a lesson. Yeah, it could just be flux. It could be, but it could be flux wash from a sudden heat event in the area. Because I'm looking at the pins of L1 and they're looking a little weird. But again, it's not concrete evidence of anything. We've just got a stack of suspicious things. So good eye, but I wouldn't chalk it up to anything individually, but it might be because we got excessive heat in the area. It might be. So we're just kind of going over the board. I'm just going through the board and I'm taking a look at what the status of the board is and what design weirdnesses I hate. Good Lord, just get a right angle switch, man. Just there's like thousands that aren't. Yeah, okay, so that's that side of the board. Now we're on the Pico Pi. So we've got a Raspberry Pi and then a Pico Pi sitting right next to one another. And we soldered pins into this. And we're looking pretty good. I don't see any big issues between these. We've got a lot of good headers, though. We've got headers that we can utilize in order to see what signals is running around. I don't know what the hell these guys are. Probably either isolation or, I don't think port expanders, but they do go into all of the sensors. These are all the sensors. Some Hall effect sensors. Boards and speakers. That's probably a speaker driver, I'm going to guess. Look at how much room there was. I will put a resistor here, and then I will put one down here, and then all the way down here, and then all the way down here. This for like a real product, like a professional product. You'd see these bunched up into one of those surface mount resistor arrays. Look at that. Beautiful. So all this stuff looks pretty much fine. I mean, it looks like no damage at all. But now we are getting into the DIY portion where a friend of mine has made some modifications, and so we've got to take a look down there and see what stuff we see. Now, keep in mind, we are getting towards these motor connectors, and these were the things that blew up. We had MOSFETs explode. See a little scorching right there. So what happened to this area? We'll have to check to see that our diodes are still diodes. This is unfortunately the result of the tab sucking all the heat away from the joint. This probably cold welded and it was enough to hold it for a little while, but then pop goes the weasel. Q6, we're gonna have to see what the identity of Q6 is. Why are we adding a resistor in here? Probably because this would be an adjustable regulator and it's probably meant to get a fixed regulator and maybe one of those more modern fixed regulators where it's like weird size and outputs a particular voltage. So maybe we can replace this with the proper one. I've been buying a lot of that stuff for the music things and I don't think, well, LM1117, that's not 24 volt compatible. So we'll just have to see what parts we can find or source there. You could, yeah, a little like RTV silicon, or I don't know if I do hot glue because this is the power supply right here. And you can see by all the flux that's everywhere. It's been, I don't know, it's been pretty heavily soldered in. Geez, I'm gonna need to put up a heat dam and then heat all this and get that out of there. And we'll have to see that the diodes are okay. We'll have to figure out cleaning out all the stuff. So yeah, the ESC connectors, those don't look 2.1 inch compatible, huh? Look away, look back and see this. Yeah, there's a little bit of custom modification going on here. There's nothing wrong with this, although I would try to saddle the resistor right here. Just saddle it right there next to the thing and have these leads be a little shorter. because at that length, when this thing is buzzing around cutting grass, this is probably vibrating on a very small scale, and that eventually led to a cold solder joint letting go. This modification is fine. Much larger soldering iron needed to get this thing to flow and stick into place. Or if you're really good at soldering, which I don't, my friend doesn't have the microscope, you solder it here, get a surface mount resistor and just drape it across these two. This doesn't go down to the bottom. This is at the top of the chip. So there's like a lot of space under it, but if you could just drape a resistor across it and get that to solder in, that's tough to do. If you don't know surface mount soldering, it can be really a hassle. Let's check these diodes. I want to check these diodes before we do anything else. So yeah, anyway, this is a Classic 500. I don't know what company makes it. Classic 500, probably remote control mower. It has all of the buttons and stuff on the back. It's got a little rain sensor, which I think is super cute. And this big spread of buttons, awesome little mower. That uses just a little plastic flywheel and like razor blade things to cut your grass, modified with open mower. And it seems like it's, open mower's screw location compatible with that system. Man, I'm burping. During my off time, I smoked ribs for my Wednesday. Smoked ribs in the smoker. We only had Sweet Baby Ray's, which I don't really appreciate that much. I don't like that barbecue sauce. But they turned out really well, and then I made them into a sandwich today. And I also made collard greens for the first time. They're pretty good. Pretty darn good. I know I've had collard greens before. I wasn't exploring a brand new thing. It's just making them was interesting. It's going to be pretty easy to make next time. We got a dead diode. No, we don't. It seems like it's a Schottky, and it is a very low Schottky because it sets this thing off. Less than a volt? Seems a little suspicious to me. Suspicious. The most sensitive Schottky diode on the planet. But then when I go this way, it seems to be blocking. Maybe they're just very expensive. Let's try the next one and see what happens. Wow. Okay, so in diode mode, a diode is a device that has 2 layers of silicon, same spec, and it's designed to stop the flow of electricity when it's in reverse. You have basically 2 pieces of silicon. One is doped with electrons and the other with spaces for electrons. And when you have 2 charges together, they make a barrier of opposite charges. Opposites attract and all that in the atomic level. And so when you have that barrier zone, it'll block the flow of current until you get to a particular voltage, and that barrier zone has grown enough to allow for a connection to the other side. That's just the basics of electronics, and when you explain diodes, that's how they are. Typically, a diode will have a 0.7 volt drop. Schottky diodes are designed with different materials in order to have a much, much smaller voltage drop. If you have a smaller voltage drop and less resistance across your thing, more current can flow through without creating heat. Heat is the death of electronics. And so with a typical diode, if you connect it without something like a resistor in order to limit the amount of current, it will simply allow as much electricity as it can to flow through, and then that innate resistance of the diode will create heat, and that'll create enough heat to kill everything, every living thing. So everything will explode and light on fire. So that's the dramaticness, the drama of the diode. So what I'm doing is I'm coming in here and I'm hitting it with a very, very small voltage. This is running off of a 9-volt battery. It's a fluke multimeter. These 2 pins will ramp up the voltage until it gets it to flow. Using, I don't even know what kind of circuit structure it is, but it's designed to minimize the amount of current through the diode. And so what it'll do is activate the diode in one direction, and in the other direction, nothing happens because it is blocking that voltage. So when we build up the charge in one direction, we can see it. And then this thing has an alarm for when there is a very, very low voltage through, because typically that would mean that the diode is broken, that it's letting stuff through with very, very little resistance. But it turns out it's blocking in the other direction. And so my assumption is that these are very low voltage diodes. Let's check the ones that are drowned in flux. Okay, maybe you. That's not going down all the way. Maybe those two are broken. Okay, let's try this one in reverse. Interesting. Oh, there we go. That's not a result of the flux. So these are showing a more healthy 0.1. So now we gotta actually look at the specs of the diodes and see if they're in line with their own specifications. These seem to have a whole part number on them because they're so big. We can also look in OpenMower to see what parts they have on their main board. Luckily, you know, being open source means that I do have the ability to look up part numbers that I don't know. So SL54F, 244 SL54F, and I don't know what manufacturer that is. 244 SL54F. And we know it's a diode. Diode datasheet. That narrows it down enough for us. If we didn't have much information, I could potentially look up any numbers that are on top of the diode, and then the package type being the body of the diode. And sometimes you come in and use calipers to measure it. We're everything's flowing all right? We got, hold on, let me just check with you guys. We got Twitch running. Father, you know what's funny? This is the second time I've ordered Domino's while watching your stream. You got a free pizza with it. Well, that's, hey, look, that works. Maybe you should, you might want to think about some healthier choices. I guess it's been a day, but you're talking to somebody who barbecued ribs yesterday, so I guess maybe I should be making healthier choices too. Okay, it is Schottky. Surface mount Schottky barrier rectifier. Rectum, hardly knew him. So the SL54F from MDD. Plastic package, but it does have a UL listing. Surface mount, metal silicon junction, low power loss. Yeah, I saw that. Built-in strain relief. What? High forward surge current. High temperature. Method 2026. What? 40 volts. RMS is 28. DC blocking of 40 volts. Forward rectified current, 5 amps. Typical junction. Okay. Oh, we only get that for the data sheet, huh? There's another page. Instantaneous forward voltage. Okay, so, I mean, I guess the diodes are okay. It seems like they're okay. Speaking of rectum, should I read the rest of that comment? Do you think you could use AI to find that song about sandpaper and a butthole? That would assume that it's somewhere digital, and it might not be. It may have gone from an analog recording directly to a record. We're talking about a record that I found in a shop, in a record store in Philadelphia, that actually, I'm friends with the people that ran it now. Anyway, so I don't know what happened to all the records. I haven't asked, I haven't had a chance. But this is a record that I found that was all just like these really silly fetish songs. But you have to understand, like, there's a whole like record industry in Philadelphia. And so it's possible that this thing could have been done as a joke, as a one-off thing, and barely even saw like a real recorder, and was transferred over to a record, and they took a couple like bondage photos for the cover, and then that's that. You know, there's like 60 copies of the record or something. Maybe that's not the case. Maybe it is famous. Maybe the internet knows more about it than I do. But it was a trip, that one. It was, you know, I got the sandpaper ready, spread them cheeks. Like, it was that kind of thing. Very weird and all fetishy songs, but we found it at a techno store off of South Street called 611 Records. His favorite record store, even though I didn't have a record collection. And my friend listened to it while we were at the shop, and he didn't buy it. He should have bought it. And we left, and I've never seen it again. Or heard of it, or had a couple sessions searching for it on YouTube and didn't find anything. So who knows? That could have been one of the rarest finds in my lifetime, and I let it slip through my crack. I mean, the crack of the hands between your fingers. It's not the... Anyway. All right, so anyway, these are Schottky barrier diodes. The specs on them are a little bit different between one pair and the other pair. The ones that are swimming in flux appear to have slightly different specifications than the other ones. But that might be because they are swimming in flux and or they are on different parts of the circuit. This is kind of a no-no. This is a no-no, and maybe for Momo they had to make the no-no. Maybe they had to do this. I wouldn't ever suggest that you do this unless this is... Okay, this one's connected somewhere else. No, it looks like... Hold on. I'm gonna stay my judgment until... Yeah, this is a no-no. We're using them in parallel. When you do this, if one of you fails, the other one's gonna violently fail. It's not good. You're spreading the statistics of stuff failing across multiple devices. You know, sometimes it's necessary. Sometimes they do, you know, where are we? We're going here. You do capacitors in parallel in order to make up for like a big capacitance. But you do that in a way that if your full 24 volts hits the capacitor, it doesn't blow up. In this case, we are multiple switching over devices. So this would be like if you double up your MOSFETs. It's not good to do. It saves you space and maybe a little bit of money on the board, but it can lead to catastrophic failure. I wouldn't have done that, but then again, I don't have an open source vacuum cleaner. The lawnmower setup. I really want to clean all this flux. This is going to be a kind of a beast to clean, though. I need to get a bunch of paper towels over here. I don't like all this flux. I went outside for 2 minutes to check the mailbox. Huge mistake. The air is bad. Yeah, so here, you guys can't see it because of the color correcting camera that's set at like a slightly warm tone, but it is yellow outside right now. Pennsylvania's getting just the tip of this right now. I've closed the window, so I'm actually very cold right now. Fire smoke. Yeah, we're down here. Does this need to be real time? What is going on? Yeah, so right there is where I'm just next to Philadelphia, right? Technically, I'm in Philly. No, not technically. Not technically, but according to me, I'm in Philadelphia. I wish I could be in Philadelphia. Is this going backwards? What the hell? Pause that. Yeah, so we're just, does that mean it rolls out? 7/18. Oh, that's a prediction. So it rolls out at around the 18th. So right now we are not there, we're here-ish. Yeah, so we got this stuff bearing down on us. Every now and then we get Canadian air and it's nice and cool out, but you know, then we get Canadian wildfire smoke. So AQI here at the moment is 316. I don't know what that means. The air quality index is out of what? Yeah, it's the 16th today. I had to go look at the clock on the computer. Hold on, let me get paper towels and we're gonna get the goof off on this thing. I think I need Q-tips too. Yeah, we're just starting to get the smoke over here. Smoke. And it is not fun. Let's see, I've got a toothbrush too, so we can actually really get this stuff off of here. I can get a nice clean circuit board as a result, but in order to do that, I need to do some a little mountain climbing around my simulator setup, which sits between the two desks here. And at this desk, I have the Q-tips. The other desk, I have everything I'm working on. All right, coming back to it in a minute. Yeah, so yesterday I broke down the synthesizer completely, and I'm gonna slowly move stuff back in and get the vinyl out of the edges of the screws. Right now, the synthesizer looks like this, but I had it working yesterday, day before yesterday. I'm gonna rearrange some stuff. I got a couple more PCBs to order. I got a filter to build. I really wanted for the pick and place that we're making to be active so that I could build this filter, because there's a lot of little doodads here and we could make it look as professional as this board. But I feel like maybe I need to just go ahead and build it. So when my new soldering iron tips come in the mail, we can maybe start on this build. This thing is a crazy, crazy filter. And they've layered multiple PCBs, but I don't think, yeah, this is 0.1 inch spaced. I think they have millimeter spaced headers on this. So I'm gonna have to buy a bunch of millimeter spaced headers to make this work. 316 out of maximum 500. 2.5 is fine particulate. Anything above 300 is considered extremely dangerous to be out in. We're not at extremely dangerous here, but I know people have been recommending masking up to go outside. That's crazy. Crazy, crazy. And I guess out west they have to deal with this stuff a lot. The whole giant Canadian wildfire. All right, like that. And then goof off. I use goof off. I don't know if I would suggest you use goof off. The reason I use goof off is that the acetone is powerful enough to really get into the flux and get it out quickly, and then I can dry the board and I don't end up with the plastic damage that people seem to think is going to happen from using goof off. So let's just flood that zone. Flood the zone. And then we're going to move it around with a Q-tip because it'll bust up the flux. There's enough flux that I think I'm going to have a little bit of a problem cleaning in this method. The first few passes are going to just brush it aside. Let me just get the resistor out of there. Let's just get that out of there. We're going to fix you, Momo. We're going to fix your power supply. Before I even power this thing on for the first time, I think I'm going to address this. It wasn't a bad fix. It maybe needed a little bit of help to make it a little bit more long-lasting of a fix, because it seems like it's prone to failure eventually, just by virtue of the mechanical stuff. But we've got the tools to make this a professional fix, or just replace the whole thing with the appropriate part. And there's so much flux on it, I can't read the part number. So we're going to do a little bit of flux, flux, fee fi fo flux. I don't know. It was I don't know what solder my friend's using, but it has like a clear flux in it, a clear rosin core. It's this weird goopy slime. What up, Jay Nico? I'm starting to get into building baby bots using Pi's, Arduino, and ESP32. That's essentially the technology that we're looking at here. You might want to look at the Open Mower project, because we are using Raspberry Pis, Pico, which is RPi2040, not ESP, and GPS module and motor modules is pretty simple stuff. I don't know what all this crap is. We'll have to look that up later. I'm totally unfamiliar with the Open Mower project. I don't know anything about it. We were given Momo, and Momo's a little cowboy hat with eyes, little cowboy hat and eyes, and Momo needs fixing. The motor controllers are proprietary for Open Motor, and they were designed very tightly into the specifications of how much current the motor uses. And so one of them blew up, and then it's possible that soured the voltage delivery to everybody else. I'm cleaning up all this flux. What the hell solder do you have, Big John? Big John is the owner of this and the DIYer behind some of the fixes. Everything looks decent. I mean, there's obviously a little bit of soldering iron rash in one area, and this stuff was so covered in flux that I've got to give it a little bath right now. The diodes are fine. The Schottky diodes are fine. I want to take a look at this voltage regulator, and I'm just explaining to everybody, I intentionally did not have any information about this. I'm coming into this thing completely cold. We can look up the Open Mower project later and figure out what's going on. But until then, I just want to look at some of the obvious stuff, because, you know, I don't need this to connect to Wi-Fi. I don't need it to connect to my internet. I don't need that high level stuff right now. We are starting from the ground up. And so me knowing less is just a way for me to make this interesting. So I'm not an expert in this right away, and people can tell me things. And so we all come up to speed at the same time. But also, you know, it's funnier if I sort of have my stupid commentary and then people come in and tell me I'm wrong. So that's the approach to it. We've done a once over on the board, Big John. If you're still here, yeah, the mower's name is Momo, and is a good mower. Seems to have done its job very, very well. He's a cowboy. He's wearing his little cowpoke hat. But we found this. I don't know what this thing do, but it may not do it anymore. It's possible it would have survived this damage if this is like a mechanical thing, but we also see some, oh God, I'm getting flux in my hand. Yeah, ew, ew, ew. Is Momo short for motorized mower? I think Momo just means Momo. I think Momo the mower is just, by the way, I've also said today, listen, all of my friends who have transitioned know this. I try to use the right terminology, but I'm dumb. I'm very dumb. And I know that Momo is a mower. It's in the name. It's in the name. It's Momo the mower. I have called it a vacuum about 35 times today. And I don't know if I'm going to stop, but it's not out of malice. Naive, not dumb. No, just dumb. My brain doesn't work. How you doing with all this smoke out there, Big John? Apparently you should mask up if you're going to be outside for too long. That's a backronym. Don't backronym, Momo. You heartless, evil person. Okay, anyway. So I'm seeing what may be signs of getting way, way too hot over here. It could be that it just got stabbed by a screwdriver and blew up, but part of the epoxy has popped off the side of this chip. And this row of, not pins, these don't have pins, these are QFN package, quad, because we have pins on all four sides of the quad, flat, because we don't have leads here, no lead, because we don't have leads here. Why do we need to say that we don't have leads twice? I think flat describes something else. Whatever. Anyway, QFN, quad, flat, no lead. We have quote unquote, well, we have pins on all four sides, but the pins are flat against the enclosure. They basically wrap under the chip. They go like over and then up. And so when you solder them, they make this kind of like wet connection kind of looking thing, right? And so on this side, they look like they are not connected all that well. They look like what do you call it? Whatever, unsoldered something or others. But the point is, this may have overheated, and I'm not sure what's going on with the jumper pads here, or if they're even necessary to be messed with. I may need to get another one of these chips and put it in. That may be part of the problem here. This is why we're doing this low level of an inspection of this thing, because this thing had an event that may potentially take out any new motor controllers that we put in place there. And I think our best bet is probably just to put better motor controllers in place. I'm just cleaning up some of this sticky tacky flux crap that's all over this area. These diodes seem to be okay. They're Schottky barrier diodes. They have very, very low voltage drop across them. And I guess that's by design. I guess that's actually supposed to be like that. Now, there was a big old resistor that was hanging off of this area that I took out because it was half unconnected. It seems like perhaps, and this is again just theory crafting on my part, this little guy right here, yeah, if you could type up what happened, that would be good. I think I got it mostly when I explained it before, but there was a resistor across this, probably because this is not an adjustable voltage regulator, or probably because this is an adjustable voltage regulator, but it's going where a non-adjustable voltage regulator went. And so the resistor is what gives it that adjustment. And it was a floating resistor, but not enough heat on the big tab because the heat wicks away almost immediately. And so the top of the resistor was not soldered on. It maybe mechanically separated itself at some point. That's the charge circuit. So this is for charging it. Okay. Well, it explains the diodes. I'm gonna try to get a brush in there with a little bit of goof off. Goof off. It's orange scented. Acetone. Why you betray me? The inrush killed the charge FET. Is that what this is right here? Is the charge FET? I see. The resistor's affixed to protect that. So it needs to be, does it need to be like a big resistor? I can put in a better setup for that. So it doesn't, because it mechanically was hanging off of the side of the thing, and I think it separated itself in all the hullabaloo getting from one place to the other. That is really stubborn. Can I pick at it a little bit? A giant, oh my God. No, it's okay. It's just flux. It's just flux. Holy heck. It looks like wax. It's a weird kind of flux. It's not the stuff we're used to with our solder. Everything was designed with such tight tolerances. We mentioned we already said they're German. You don't need to say that again. Where's LED TV Live? I needed German here to make fun of the Germans. That way I don't feel like I feel like I'm ribbing them instead of making, you know, mean jokes. Okay. And then, so yeah, everything is designed with such tight tolerances that any sort of variation killed it. The resistor fix was an old fix, but the motor controller thing was basically me short-circuiting the heat sinks. And I heard a fuzz noise, and then Momo died. Yeah, so the MOSFETs, well, I haven't taken out one of the motor controllers yet, but those MOSFETs are, what's going on? Hold on. I guess that's okay, is it? It seems to be leaning to the side a little bit. Might want to take, well, I don't want to melt this, but I don't think I have a good heat barrier that I can deploy there. Yeah, this thing is leaning to the side. I don't know if my soldering iron, I've got new iron tips coming in the mail because my big tip, my big iron on my tip, big iron on my tip, failed. It just stopped working. So I've got $100 worth of iron tips coming in the mail. Pace has a minimum order cost of $100. I guess that's okay. They were like 20 bucks each. I got like 5 iron tips coming in the mail. We will finally have a drag soldering tip. I hot aired on that and coached the Molex. Yeah, okay. So that's a hot air injury. Wonder. Wiggle, bounce. So that all works, right? The charge circuit works. So I may find a big 1206 version of this guy and put one of those in there. Or like I was saying earlier, if I just put it across these two, that could also do it. But if I were to do, like, because this is leaning a little bit, and that's neither here nor there, all the connections that it needs to make are being made. So maybe we don't do that. I don't think I need to reintroduce hot air to here just to push this down a little bit. It was in my lawn and portable soldering iron making the one hot fix on a summer day. That's funny. That's crazy. I mean, I could try to lay it down with the iron. I don't think it's going to lay down, though. Yeah, I don't know. I want to use hot air, but if I put a barrier here, I think enough heat is still going to get by that it could potentially damage the Molex. So, which is why I want to solder from here to here, because those also have smaller connections to them. They'll solder much easier. And then I assume, so if this is all working, let me do a low vibration fix on this real quick. Because having a resistor hanging out in the air is not ideal. It's not ideal. What resistance is used? What is you is? Is you is or is you ain't my baby? It's from a real artist, but I know it from Tom and Jerry. 10K. Oh, you've just put that in chat. Do I have any 1206 10Ks? I really don't think I do. Could I steal them from other electronics? Do I have any 1206s? 0805 is really the size that I normally operate in. So if I were to source something, there's like a big, what uses big surface mount? I don't think you're going to have anything. No, these are all too small. Yeah, I need something from like the early 90s in order to find a part like that. Oh, maybe you got some old 3D printer board. R100? Well, that would mean they're probably 10 ohms. So let's see what they are. If only this was, if this is 10K, I'd be so happy. I would be so happy. I'd be a real boy. 1 ohm. That's 100, so 1 with 0 zeros after it. What up, Haystack? How you doing? Why, by the looks of it, we appear to be helping out my friend Momo, who's a robot lawn mower, who's got a little hat on, got a lawman hat, got his little lawman hat and his little googly eyes, and we're helping him with his electronics because he apparently blew up a bunch of his MOSFETs. So as just a thing we do here, we look at all of the electronics, and when it's something like a piece of electronics that a friend owns, I can't let certain things go. So we're just kind of fixing up this charge circuit a little bit so it doesn't blow up and it doesn't have a through-hole resistor soldered sort of dangly to it. So just need 10,000 more. Okay, yeah, if I use all the ones on the board, I'll have 1, 2, 3, 4, 5, 6, 7, 8, 10 ohms out of 10,000. So we're getting close. We're getting close. Yeah, I'm looking for a big like 1205 pet the special dog. I'm not petting this. I don't know. I'm not gonna do that. I don't feel comfortable doing that. So those are not what we're looking for. Those are basically just limiting the inrush from the stepper motors of the 3D printer. And I don't think I'm going to find any other large resistors. This is a fairly more modern board. There's a couple fuses on it, but yeah, the 10Ks are going to be in this 060 whatever, 0608. The best I can do, I guess, is 0805, which will hopefully be able to carry enough current. I don't think I've special ordered any 10Ks lately of that size. I don't think I've needed anything like that. Give him belly rubs. There are razor blades in Momo's belly. I am not doing that. It's no. All right, so the 3D printer doesn't have anything good, and I'm sort of hard pressed to find any 10K resistors that I could find in my box of tricks, because 1206 surface mount kind of is a little niche, really for higher current stuff. And most of the industry moves to smaller and smaller components. So you don't really find stuff like that in something like an old GeForce 4. I liked my GeForce 4, but I also cut it into pieces because I needed a big PCB to solder stuff on top of. But the GeForce 4 has been a source of weird high current stuff because it's got this whole power supply section on the back here. It doesn't look like any of this is really relevant, though. None of it is 1206, which is larger than 0805. It's a nice intro to surface mount size to solder. So if you're looking for a project, find something that has a lot of 1206 surface mount electronics. My go-to is really 0805, and then 0603 has been the latest in space restricted applications. The only other place I would think to find it would be on that sound card. Where did that go? What's this? Do you have any big... No, you don't. No, all the resistors are so tiny. Nope. Nope. A lot of tantalum caps, though. I liked this thing. Oh, well. Dead. All dead. All of it. Dead electronics. Dead. Super dead. Okay, let's just get a regular old 10K then. Surface mount. Which I've got lots of. Go. And the trick is that on this device, the reason I wanted to kind of sit it down a little bit more, on this device, the tab And we'll just double check. Goes to this pin. Yeah, there you go, 2 ohms, 3 ohms. So yeah, the tab is also connected to this floating pin. So what I can do is put the resistor from here to here. I mean, the alternative is that I would scratch up like there and go from there to there, but I guess we'll keep it as minimalistic as possible and just go across like that. I assume Momo made a nice satisfying fwee sound. Fwee, fuyo, and then let the magic smoke out at some point. That is one for Big John to answer. I can't imagine fixing something like putting a resistor on this thing in the middle of a summer day, like in the middle of the lawn. Sounds awful. We need to clean up a little bit more though. There's still some residual flux in the area. I'm gonna hit it with the Q-tips again. We'll get what we can. Basically, at a certain point, with my defluxing method that I just used, we're just gonna be pushing around sticky stuff. I don't have like the. Where did I go just then? What was that? Put it in the dishwasher? I mean, like people have ultrasonic baths for stuff like this. My ultrasonic bath is not big enough for this, so I can't quite do that. You can wash it. Do you have like a giant ultrasonic bath? See, I've got a decently sized one, but it's not. It's called a dishwasher. No. That's all right. The flux isn't doing anything. It's fine. Build an ultrasonic bath. I mean, I could modify my small one. What's going on here? Hold on. Additional refill. Wait a minute. I've got CVS Pharmacy. Oh, been received and repairing. Okay, cool. That was for my ADHD drugs. You ever want to get treated like a criminal? Try to get ADHD drugs, even if they're prescribed. They hate giving those things out, man. And far be it from your average ADHD-stricken streamer to be able to keep up with schedules and stuff and get prescriptions. All right, there. Okay, so this is a little bit cleaner. Not a big deal. It's just that this whole place was drowning in flux, so it's meth. Not really. I'm not ashamed of my flux. There you go. You should not be ashamed of your flux. It's all totally necessary. There's probably a couple boogers in between these, huh? A little bit of boogery. It's a little bit boogery. All good, though. So much cleaner. I mean, the board doesn't really need a wash. Now, if I were to try, I kind of want to try to sit this thing back down just because. And so what I'm going to do is get a big piece of Captain tape. Captain tape is a high temperature tape, and we can use it to create a hot air dam that will prevent the connector, the plastic connector, from melting. And I got these new things. Check it out, guys. Check it out, chat. I could call you. Hey, chat, are we cooked? That's how streamers talk, right? I'm a streamer. What do you do for a living? I really don't want to explain to them. Could you just cut my hair? So whenever I'm in that situation where I have to explain what my job is, the go-to, and this is only something that Bother can do, well, you guys could do it too, you say, it's engineering, it's a lot of spreadsheets and stuff. Yes, prevent it from melting further. All right, everybody's a critic. We could use chip quick on the connector and actually like remove it and get it out of there so we don't harm it any further. And that means that I could also probably take a file to it and clean it up a little bit. We don't really need to do that. What I'm going to try to do is put a big piece of Captain tape right on the side of the connector so that as we're applying heat to that right there, it doesn't, strike it and melt it immediately. I generally tell people my title, then I have to explain what I actually do. My name is Sir Mondemont the Third, Lord Herald of His Highness's... Sorry, you said title. Titles. So these things are cool. They're these big rare earth magnets with cups around them. The cup focuses the magnetic energy and helps keep it around this edge. So you have north and south very close to each other, and when you put that on a piece of metal, it'll stick to it really, really well. And then these have these little jaws on them. I may replace these with silicon because I don't know what the temperature stability of these are. These are metal, this is metal, the ring on it's metal, the magnet doesn't like heat, but it's far enough away. So I think I can actually use these when soldering. And I've got a giant steel plate. So I think what I can do is put the Momo brain into this thing. Oh my God, these things are... We are learning. Look at that. That's cool. Creating AI porn isn't just my profession, it's also my hobby. I don't know if I'd get a good haircut after that. I'd either get a really good haircut or a really, really terrible haircut. What? What are the things that I'm saying? Oh, I didn't look to see when. I guess we got 30 minutes until an ad. Sorry about that. I wasn't cognizant of my ad schedule. I took out the ad warning light. I need to make another light into the ad warning light. Oh, that was a terrible thing. That was an awful cut. I need one of those duck grabber things. It's pretty cool. Although silicon tube around these would probably be a very big improvement. But we're going to try them out. And then we're going to build a big... Didn't really just do that. Build a big air dam between, you know, right there. And I think that'll prevent any damage from the connector. The other thing that I would advocate to do is plug a connector into the connector, but that's the battery connector, so I don't want to do that right now. And all I'm trying to do is get the solder to move a little bit so that the, whatever it is, the FET or whatever TO220 device this is, just lays down. I want it to lay down flat on the board. So with that loosely against the Molex connector, I'm going to press down here so we don't get anybody coming into there. Keep the heat away. That should be enough to keep that from melting if we concentrate our heat to this area here. Let's back up a little bit. Assuming the camera can still focus. Yes, it can. All right, now get the hot heater, hot heat over here. It's like once I found what works with the hot air, I don't really change the bits. We've been using this size nozzle for like a century. Oh, let's turn this on. And then we'll put a 10K resistor across the bottom. Now I guess I'm going to take the pin tool here just so I can, because I think at a certain point what I'll be able to do is just push down on it. Yeah, this is my first time trying these little duck grabbies, but they're actually really good at what they do. Seem to be anyway. So start with the heat far away in cycles. And probably, you know what I'm going to do, just to be nice, do a little bit of tachyflux. I was saying if I was going to do the through-hole resistor, I might have put it right next to this thing so that it was right here. And that way it wouldn't vibrate as much. But we're going to do a surface mount resistor, and it'll be just across those two little tabs. And I think it'll be just right. So since this thing is connected to a giant ground plane, I would either want to come in hot and fast with a big soldering iron, mine of course died, or heat up the area and then press the issue. So I'm coming in from far away, and I'm going to start moving a little bit closer and closer. And I'm actually using the stand as my wrist rest to keep stable. And I'm going to try not to blow air in the direction of the Molex connector. or any of the other plastic elements that are nearby. All right, let's really press it. Get that to flow. The pins are flowing. The big guy. All right, push down. And we're in. We're in! Hacker.exe. Does it look like it's leaning back? Yes. All right, back in. We're back in. We're coming back in. While everybody's still warm. Come on. Okay. Any more and I'm going to get nervous about the... Oh, God. Put it back. Okay. Anything else is we're not doing. I'm not touching it again. We got that nice and gloopy. Yeah, it's still like picked up a little bit, but it's a little better than it was. There's a lot of solder there, as evidenced by the bead. But it's all good. Good enough for me. So now that area is going to be pretty hot. I'm going to wait a little bit before I get the 10K out here and solder it in. Just get the hot air gun over there. Soldering it. Oh, it's nice to work on like real electronics again. All the synthesizer stuff doesn't feel like real electronics to me. Don't let Sid Heresy hear me say that. So I'm going to go in with a high performance. So I have this big heater here. That means, well, actually, you know what? I don't need to. I know that TO220 package is going to suck up a lot of the heat that I've got in the iron, but I think I might actually get away with, I probably want a slightly larger tip on it, just because I know that the heatsink pin is going to want to suck all the heat out into the heatsink. But if I act quickly here, I can still get to it while all the residual hot air heat is in there. And that'll help me do my job a little bit. So we're going to get an 0805 resistor in here. And I will solder it to the bottom leg first because there's a huge excess of solder on that pin. These are my 0805s that have had coffee spilled on them. It's one of these guys. Smell hot plastic. What do I smell hot plastic? Looks like my little grippies are fine. And the Molex connector is doing okay. So I think we did good. I think we did good. Oops, got multiple of these. Hold on. You guys are seeing what I'm seeing. So, all right, let's get close. Get to the right spot. This is the second red circuit board that I've worked on for this person. Not that that's significant, but it, I don't know, something. So this is like an inrush limiter, huh? Now, here I've got to go crossways to do this. Maybe if I remove solder from the leg, and then we'll solder it to the right, because I'm right-handed, so this is kind of switch hitting for me. So maybe if I just get these out of the way. It would be cleaner if I could do from here to... Well, that goes here. That's there. None of y'all... Okay, so those all connect there. If I put it like here, but I guess we want it to be first in line. Usually that doesn't matter terribly though. But I'm not totally sure in this application. So if I put this here, like that electrically, that would be what works. Okay, now it's gone. As an abundance of caution, I guess I'm going to put it right next to this thing like the old resistor was. It's gone forever. It's with Wyclef, wherever he's gone, forever. That was in November. Oh wait, he never said forever. He just said gone in November. I don't know if the distinction is completely important there, but... What's up, Groovy? How you doing? How you doing? We got Momo, the robot lawnmower. Oh, I said the right thing this time. Proud of myself. I'm floating a little 10K resistor in here, just like was there before, but before it was a through hole, and it probably suffered from the heat wicking from that tab, keeping it from getting soldered properly. So what I'm gonna do is let's put a little solder on this piece right here, and then we'll press our 10K down, and then I can put a little bit more solder on. Yeah, if I were to do field repairs, I would really need those very, very cool magnifying glasses that I have. Okay. Oh, there it goes. We've got enough material on there. This is basically like a residual. Usually in the past you have 3 pins on this, but if you're in a high current device, you maybe want that space for big traces like they did here. So instead, they cut that pin at the factory and used the tab as that interface. So that's the situation that we've got with this device. This is bugging me. Oh, am I even going to be able to? Nope. All right, I'm gonna leave that alone then. You know what? You do you. I'm not gonna mess with that. Okay, 10K. Put that right here. Can't see how high I am. Stoners and microscope users. Clap. Please clap. Literally chilling. Yeah, that's the situation I'm in too, because of the Canadian smoke making its way all the way around here. I have had to close the window that normally regulates the temperature in the shop and keeps me from freezing to death. No, it looks soldered. Oh, because it's wicking the solder down to here. No. If I ask you guys to clap, you do not have to clap. Okay, so there's a 10K ohm resistor between those 2 pins. Now this will not vibrate itself off into oblivion. Which the other one, maybe it wouldn't, but it certainly didn't seem, it was a little bit kind of like cold soldered on. And as soon as I touched it, it seemed the tab up here was not properly soldered. So like the resistor's connection to the tab. Now I don't think I'm going to be able to put enough heat into this thing to make this molten, but I would like to get some of that excess solder out of there. Actually, it looks like I might be able to. Oh, that made a little noise. Oh my God. That was very satisfying. I'll put a little bit of solder on that. We want to make sure that that thing can... Whoa, deja vu. Why am I getting deja vu? I've just been in this place before. Deja vu. That's more like what it should look like. It's a little crooked right now, but you know what? We're not going to fix that. I'm not, because I could be here for days trying to make this look professional. And I think it looks professional. It's got fully It's fully attached with solder. We do not have an excess there. That will wick away the heat perfectly. We've got a little bit of an excess on the two pins there, but we now have a 10 kilo ohm resistor, like what was there before, across those two leads. And let me just check that electrically it is indeed connected with 10 kilo ohms. Now, I don't know what that inrush is. 10K is a lot of resistance, so I think this will be okay there in terms of like the wattage of the resistor. I don't think this will be apt, you know, primed to like blow up. Obviously, the through-hole resistor will be able to take more, but this is 10.16K. The one that was there before was 9.9, so we're 0.3K. The resistors from Q5 to Q6. Not just on Q6. Which one's Q? Well, there's Q6. Where's Q5? Where are Q? Oh, from Q5 to Q6. So that was what I was talking about before, was I was thinking, instead of there, can I just put it right here? I would kind of rather put it right there, because this is kind of a non sequitur location. Yeah, maybe I'll put it, instead of floating it on the pins like that, because that's nothing wrong with that, but it is just kind of a weird place. Now that I know that this iron can melt the solder on the tab, we can not involve the tab. I've just been in this place before. Deja vu. The trigger voltage from Q5 is too much for the Q6 sometimes, which is why the resistor is in place to protect the gate. I want to put this is a non sequitur spot. I wanted to see if I could do this, and I did, but I think it's a little bit sloppier than doing it properly, which would be to put it down on the board, because we've got two pads that are like an 0805 device apart from one another, so I might as well do it the right way. It's just I'm playing right now, you know, player play and all that stuff, but let's do right by this, you know. Deja vu. I've just been in this place before. Okay, dried up some of those pads. And we're gonna wet the dries, dry the wets, etc., etc. So now I need to get another 10K, which I've just got 10 million of them sitting right here. Buy resistors in bulk, or rather 10K, 1K, etc. Those are the ones that you need a lot of. Seems like 4.7 is coming up a lot more with digital electronics. I don't know why. I don't know what 4.7 gives us. Where did it go? I just had it. It was almost there. I almost had it in the right spot, and then I felt it leave my tweezers. Let's hold on. Invert Momo's brain. Shake. There it is. So now I'm just going to put this right here between Q5 and Q6, because this trace, fuck, hold on one sec. Probably have a good deal of resistors scattered around the room. Well, double check, 103, 10K. So we're going to go from here to here, because that's the resistor went from here to here, which that is connected to Q5. So just a little flux there. And that'll keep it flat to the board and keep everything traditionally connected and all that fun stuff. Oh, it's beautiful. 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 There I am, doing everything I can. Bud. There it goes. Starting. A lot of stuff to heat. A lot of golf. A lot of golf to get to. All right, there we go. Adding a little heat. I can just hold you there. If the solder would flow. Having a burger. Hold on one sec. I'll read that in a second. I can't. I just can't. Okay, that for now. I'm gonna have to heat that up again. But now I can do a little bit of solder. A little bit of solder in my mind. There we go. Those two are connected now. And then get this over here. A little flux involved. Just make sure to flow over the whole thing. There we go. I wouldn't say it looks natural, but it does look like it's a lot neater than what I did before. Yeah, there we go. Okay, so now there's a 10K between Q5 and Q6, literally. It's right in between them. And it's got the flow to it. It looks nice. Everybody's happy. How about that? That's not what I was supposed to do, but I did it anyway. So we get a paper towel here and clean off our flux so it looks nice in this area. That's that part. The other part is just ensuring that the power is there, and it seems like I need to order a part because I don't trust this to still function. It seems like it's soldered a little bit weird. And we're probably gonna have to look through the GitHub to figure out what it is. We can see the part number on it. Maybe we'll just take a quick look and see if we can find out what it does. What's up with Speedy? I ordered up some burgers from Casey's. I don't know Casey's though well. Because I feel it's shit to go out or cook anything. So you'll have your delivery driver go out. Here, you inhale all the smoke. Here's some money. I'm not going to the hospital. You go do that. It's funny because yesterday I smoked ribs. I smoke rocks, Joe Rogan. No, I smoked ribs yesterday, so my hair is full of smoke. And then I woke up today to the whole area being just inundated. Okay, I'll let you know. We're gonna look it up right now once I clean this. What's up, Gonad? You don't got any of this Canadian smoke in you, do you? Oh, is this whole part crooked now? Oh, geez, Louise. I'm not going to be able to sleep at night if it is. I think because of the parallax of the camera, I didn't see that the part is actually a little bit crooked now. I don't want to go back into it, though. I mean, it was easy enough for us to do. I don't think we harmed the connector any more than it already is, but it's, you know what? Everything is making connections. I'm not gonna lose sleep over this. This thing is perfectly in there. I do not need to be messing with it. I'm gonna add just a little bit of solder on that. It's fine. I don't need to. Why am I doing this? No, it's not a. Yes, it is. It is. It's okay. It's okay. It's fine. It's fine. It's not fine. It's not fine. It's fine. Okay, there. Now we're none the wiser. We don't see the little misalignment. I will never forgive. Oh, bother. For 10 generations, my family will remember. It's just, at that point, Father's brain no longer functioned. He was just making noises. That was the point. True death of a streamer. Usually use Kim wipes, which is funny because our technician that used Kim wipes, her name was Kim. So like, why do you have your own wipes? She'd be like, shut the fuck up. I'm like, okay. Engineers aren't funny. All right, that looks good enough. No, it doesn't. What's going on right there? It must look perfect. Why is it like fighting me? What am I hitting? Huh. Shouldn't be hitting anything. I've got full airspace coverage up here. All right, good enough. So, all right, let's take a look at that other part, the one that blew up. I suspect that this thing might be too suspicious for me to leave it alone. It might still be fine. It might actually work fine. But a component of that nature, being the power supply for all the sensitive digital electronics of this thing, being half gone, or having the lid popped off of it, does not fill me with confidence. Why am I hiccuping so much? Hold on, I have to get something to drink. I am completely desiccated here. If people are working outside in the garden, I think I need to go punch them, because they should not be outside today. This is not good. We're going to get inundated with smoke. Although there are people doing the yard work right now, so it's like, what are you guys doing? They're not wearing masks. I'll be fine. I'm tougher than this. But like, we're talking about carcinogenic smoke. Like, this isn't something you can be tough at. But people will be tough. I mean, everybody's got trauma from COVID, apparently. Like, I'm not going to be a weakling. My lungs are stronger than that, bro. 90% of all of the issues that people talk about with smoking anything is due to the fact that we should not be taking in particulates from the air around us. The part of your lungs that is responsible for extracting oxygen from air or whatever and getting it to your hemoglobin is very sensitive. It's one of those interfaces with the outside world that our body has that we should not fuck with. Should not. These caps look good. Okay, good. Those are all good. All right, so problem area, the main thing that we saw. This, I believe, due to the test points, is some kind of a voltage regulator, especially because it's got a coil near it. And again, I'm going into this with no information. I can obviously get information if I want to, and Big John is in the chat, of course, blowing the lid off of information that I didn't know I needed or didn't need or didn't have. I wore a mask outside and it helped a bit. I wonder if more from allergies than the smoke. Yeah, that's me. That sounds very familiar. So anyway, we've got all kinds of sources of information, but our initial thing to do here is just to look at the main factors. When you have something that blows up on a piece of electronics, you're going to look for the same things over and over again. Blown up capacitors, or the big capacitors stressed out. These seem to be okay. There's a little bit of like little bowing on it, but I think that might just be from the factory. Those big caps, they doubled up on them. This is a power supply area. I mean, obviously there's a lot of room to be working with in this whole circuit. And I don't know, I guess the big voltages are coming in from over here, and this thing's probably making our Raspberry Pi system voltages and our Pico Pi voltages. Even though these have external regulators, both of them have, well, no, this one doesn't. This does have an external regulator to bring everything down to the 3 volts that it likes to use, but it's good cover for walking around with a blunt. I'm filtering through the filter on this spliff. No, but anyway, that's not spliff. Is that a spliff? I don't know. I don't know, man. So yeah, I'm filtering the outside air through all of this marijuana. It's actually a good idea. All right, no. I'm not a doctor. This is a power supply. I only know because there's a coil nearby, and that seems good enough. Yeah, that spliff is combining tobacco. What's the one where you roll the cigarette filter in with everything? That's got a different name. My Amazon lady, the thing that talks to you, upgraded us without my consent. And instead of saying, motion detected at the front door, it just went, motion detected at the front door. I'm like, who is that? I don't need a conversational buddy to speak using AI so that I can put all the wrong inflections on all of the wrong things that it says. Like, Yeah, she's got attitude now. I really need to look into how to turn this thing off. I think you can turn it off. I think. I don't know for sure. But changing her voice upstairs, I was like, stop being so verbose. And then it made itself a little bit more like, I need a ship's computer. I need, motion detected at the front door. I need, like, no personality. This is not my friend. I don't need to blow up a small town in Michigan with subaudible frequencies so that the thing that speaks to me from my wall can have a little bit of sass in their voice, right? I don't want that. Jeez, I need Apple Talk. By the Michelle Barrett. Yeah, I guess I could get that because they got all the like phonemes or whatever from Michelle Barrett so that she can forever be cursed to be ship's computer. Poor Mrs. Troy. Okay. 20405 QQ. Quit crying? Hey. Even the chips on this thing are making fun of me. 20405. Oh, QQ datasheet. This one might be a little tougher to find, but we can open the GitHub. I could do that. I could stop and ask for directions. I could do that at any time. It's not even hard to do. This is looking like Max 20405. Look at that. Yeah, look at that. That's cursed. There's a whole Twitter account for cursed pinouts that I no longer am subscribed to because I don't fucking want to go on Twitter ever again. But the unfortunate part about getting rid of Twitter, aside from the fact that the grass is greener, the sun shines a little bit brighter, I feel good, I can take a deep breath finally, and being on less social media is great, is that I don't have a connection to accounts like that, and the Japanese engineering Twitter is very cool. They do a lot of weird projects. I know the GitHub is all the info. I just talked about stopping and asking for directions. Yeah, I need to check the app, apparently, and then maybe I can turn it off. The Gerbil? What's with the Gerbil? Oh, for the PCB. Gerbil was a program that I used to run the laser board for a little bit, to test it. No, I want to look at the Max 20405. Oh, wait, that was the wrong thing. What the hell is that thing? CUI? Oh, did CUI buy Max? I think they did. CUI Incorporated is a Canadian company that made the encoders that we used in a lot of stuff. I still have a lot of Maxim chips. This is not what I was looking for. Okay, Analog Devices bought Max. There we go. So this is a crazy automotive 36 volt, 456 amp, fully integrated, synchronous silent switch buck converter. Woof! Maxim Devices makes a lot of very specialty devices. If you're looking to save money, you do not look at Maxim, but if you're looking to get a specific ASIC job done and get like a well-built chip to do it, this is who you go to. There are always spin-offs of Maxim products, and there are other, like for instance, the switching devices, the muxes that I have were used in scientific research equipment. They're that good. There's muxes that are much better that do a much more narrow job and switch in a different way. So Maxim is when you really need the sort of the specialty part, the Cadillac. So what we got is a very complicated ASIC that does buck stuff. I'm not sure if I can jump in and really get a good test of it. The fets, yeah, I can't get to the trigger of the fets. We can look at ground and VCC, VEA, feedback logic, boost bias. What's up with you? Pin's literally sup. Sup, man? S up, P ground. Sounds like I'm doing call-outs at the front of an album. Sync out, and Facebook. Okay, so let's go take a look at the application circuit then. So this is a pretty bruiser of a voltage regulator. And I guess maybe in the fray of things going wrong, this was probably asked to dump a whole bunch of current, which it can do, but then it likely heated up and damaged itself or exploded. Woof, look at all that. Okay, here we go. So typically with chips like this, specialized chips, you're not going to find too many variations from the suggested use. So in this case, what do we have? Single phase 2.1, 400 kilohertz, 6 amp, 2.3 megahertz, 6 amp. We're somewhere in that realm. I'm going to brave the smoke later and go out to get gyros, the only food I would consider dying for. What food is on that list for me? Gyro's not on that list for me. I don't know what food, you know, would you die for a cheesesteak? No. No, I would not. Hamburger. Looks like it says we are 2146. Where are you seeing that? Oh, this, yeah, we are. You need gyros, the actual lamb. I wouldn't be able to tell. I mean, I don't know where you get one without real lamb. So, if I'm looking at the chip, I got LX down here that goes to the coil. And then P ground is right here. As well as, oh, the other P grounds. There's two P grounds. So those are grounds. And then, let's see, sync out, sync, P good, yeah. Yeah. Output is here. Makes sense. How many ohms do we have from ground to output? I am seeing none. I do not see any. Oh, here we go. Okay, so that's kind of healthy. Oh, I see. They just do beef instead of lamb. Interesting. So you know the good places that actually have the real stuff. I don't know what my local somebody here has an affinity for Greek food, and I don't think I can stand feta cheese on the regular like that. Black olives too, I don't appreciate. So yeah, there's some capaciting stuff going on. I mean, obviously I'm measuring across the capacitors here. So I'm just looking to see if there's like an accursed short somewhere on this that indicates that something's wrong. Now, where's power in going to? Those are more power. You got two grounds here, two grounds here. Then you've got your coil. And then the other side of the coil is going to this same one over here, which is also not a ground. That's an output. So the output goes here and around. What the? Okay. Weird circuit. Where's V in? Enable. That's not V in. What the heck? Hold on. Just looking at this guy right here. I assume that this thing is connected mostly the same. I mean, there's a real ground here, and then we were looking at power ground. We have 4 power grounds on this thing. I mean, this thing is churning up to 6 amps, so no doubt there would be a lot of grounds. Yeah, Speedy Cat was saying it was beef instead of lamb. Lamb, onion, tzatziki, side of fries. Huh. Sounds good. Is it there? That's bidirectional. No. Where is our power going in? Boost. What the heck? Why am I finding this is confusing? I want to see if the chip's like very obviously dead, or if there's, you know, if it's ambiguously dead, I think I'm still going to want to replace it with another one of these. Just to be safe. Okay, V sup is V supply. There we go. What's up, V? Oh, I see. You get to build it yourself. It's nice. V sup. V yeah. Sup. Sup. Okay, so we got two sups. They're on opposite sides. Oops. So, I thought that was out. Wait a minute, what? Okay. Ground out. Ground. Oh, supply as in it's supplying the rest of the stuff with this. So there's a supply here to the big caps and everything. And there's a supply here to a lot of vias bringing the thing to the bottom row. And then we've got two grounds. That goes out to the coil. But then it's got another output pin up here that goes down to the coil. So that's that one goes around to the coil. What the heck? Where? Okay. Which pin? What is this? Wait a minute. Which pin is the voltage coming in on? Is it sup? Because I don't have a V sup. I have sup. And I have bear. Bear. Welcome to the meaning of the bears. Out is there. So these are supply. So we've got supply on two sides. This chip is weird. Maxim, could you just be normal, please? So between input and ground, I have some, like a large number of ohms. And then between input and output, which is here, right? It's second in, yeah, right there. So between input and output, this is where you see voltage regulators kind of break down if something's really badly damaged. I mean, 50K is decent. 1K is not. 1.2K? Okay, well, it's charging capacitors. That's one thing that's going on. Very sensitive voltages. All right, well, just on the basis of the fact that this chip is cracked, even though it... Is it cracked or are we cracked? I think we're cracked. The chip is streaming in the back seat. Actually, I think it's fine. I think it was just the lighting. It is not blown up. This might actually be okay. This regulator might be fine. Sorry, that was a cabinet closing and it caused giant ripples. Because as I was looking at this thing, I mean, I was getting a better view of the side of it, and it doesn't really look as cold welded as I thought it did last time. So it's possible that this thing is doing okay. You have a thermal image of the board? Oh, I would want to see that. If you can send that to me on Discord, I can share it. Here I am. Why do I have early 2000s ska stuck in my head? Like, what did I do to deserve this? Yeah, either PM or in the stream project section. I would love to take a look at that because yeah, the thermals will tell us some stuff that's going on. Although it may be focused to the actual motor controller where it blew up, and I might be able to just power this on and test the voltages that are coming out of it, and we can see if everything is hunky-dory and happy, and then we can see the Raspberry Pi trying to communicate with the motor controllers. We'll need to open up the GitHub for that. And I'll have to hit it with 24 volts from my power supply. Dun, 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 dun. Where did my Nipex pliers go? I don't know what happened to them. I must have had them on special assignment somewhere, and they've... Why is there a microcontroller sitting there? What in the hell? Wait a minute. Hold on, wait, we got more mysteries suddenly. This is no place for a microcontroller. This may be one of the ones that I removed from something. It says ARM on it, yeah. I think it's another ARM microcontroller. These things are hunting me, I think. I keep finding them everywhere. We took apart those LED sunglasses and it had an ARM microcontroller in it. Where did I desolder an entire STM32F405? Cool. All right, take a look. Just a sec. Let's get this ARM, this STM32. What am I do? What is that doing there? Those aren't cheap. Oops. That was the front of my Discord. Okay, let's just, yeah, take a look at some of these. Whoa, cool. These are high quality. Doot. That's anatomy. That's anatomy. That's disgusting. I can't believe you would send me that type of filth. Okay. So this is one of the motor controller boards. It looks like the microcontroller is screaming and ready to blow up. The bottom of it looking okay. Feels weird, man. Oh my God. That's another one of the motor controller boards, only this thing is blowing up actively. Okay, and then we got the whole board here. So the Pico Pi is heating up quite a bit. I don't like that. The Raspberry Pi, of course, has some really nice ground planes on it, so it's able to dissipate the heat properly. And our 6-amp controller that we just looked at looks warm, as it should be. It's moving a lot of energy, and the LED is also quite warm because it's a high power LED. It's a 3-color high power LED, one of the ones that hurts your eyes. So that makes total sense. And then up here, we've got some heat from either being connected to the charger or outputting energy to stuff. Where is that? That's just at the corner. Actually, that's those 2 chips. These little guys. U10 and U9, which are CD4057, 4051. C4051. I don't remember that part number. But it is a common part used to... Is it transistor? No, I don't think it's a multi-transistor. Well, 4051. Yeah, but then we get this. So I don't think that's what that is. It's something else. We can look it up later. But it might be multiplexing. It might be doing a bunch of other stuff. Who knows? Anyway, this looks normal. Except maybe, you know, the motor control. Oh, they're not installed. So yeah, this does look like a normal amount of heat dissipating to everybody. The GPS is the other one that I'll power separately and see how that's doing. But in terms of my confidence in this board that's sitting right in front of me, I think I can power it up and we can see what's going on and measure a couple voltages and see if it's functioning or not. So let's get into that. I'm just going to take a big swig of seltzer water and then let a giant disgusting burp out, and we'll get some leads and we'll see if we can hook this thing up to the proper amount of power. My test leads are probably going to be a little bit anemic for this, but I think they should function just fine. And then I got to see where the leads of the battery are going to on the board itself, if we're just bussing all of power into something or if I have to individually power stuff. Dr. Plugger, subbing with a Prime for 63 months. Hey, Dr. Plugger, thank you. I need to hydrate. Give me 1 sec. That should be good enough. All right. A little Molex. Probably have something like that somewhere around here. Do I know where? Get it out of my head, please. Please. Okay. Here is some motherboard crap. Because remember, people give you motherboard crap when you do electrical stuff. They just give it to you. They say, hey, do you want this power supply thing? And you go, no. And they go, okay, I just dropped it off. And you go, I thought, hello? I said, no. Okay, now that I've disturbed the cable bin, yeah, there we go. Now I can scooch myself back up to the desk. Is it a motherboard connection? Might be. Yes, it is. It's a graphics card connector. Weird. All right, well, let's sever this. You ever do that to your computer? I actually have on multiple occasions. Because what I like to do with these connectors is solder them all down to a PCB. So I take either uncrimp the back and put a solid wire on it, or just put the wire directly into the back of a PCB, and then I will make this with larger, much larger silicon jacketed wires, so that I've got big cables coming out of the graphics card instead of a billion 18 gauge nonsense ones. These, they used some kind of shrink wrap. EVGA used some kind of shrink wrap that has like a sealing material on it. It's got like hot glue in it or something. And so these are actually a little bit difficult to get apart. I think the scissors were the way to go for that. So I'm just making this so that I have a 24-volt test lead that I can hit Momo with, turn the brain on, and then see what voltages we've got running around, because it seems like things are probably going to be stable. So we can hit it with the scope and see if there's any like small jitter in the voltages, and then we can also take a look at some of the digital lines once we find our materials and see that everybody is being spoken to appropriately. Why is there a lump? What is that? Oh, because they zip tie the one end. And so you got to watch out for that little jump where there's not enough material in front of the cutting blade, and you suddenly jump in a direction. You always got to kind of think of that in the back of your head. 28. Okay, it's 28, not 24. Gotcha. Why EVGA? Why did you hide a capacitor? What is your goal here? And it's like a surface mount cap. What are you people doing? What are you doing? Probably don't even make these anymore. Evil, evil. What evil have you brought upon me? All right, well, that's getting cut, because ain't no way I'm going to trust Mr. Extra Capacitor in there. Okay, yeah, the other question was, are they all bus together? Well, we've got one separate line coming off of here. And then shared going up and in. Yeah, we'll look this up. Okay, I gotta answer this question elsewhere. The minimum number of lines that I would need in order to power it up. Oh, the power switch on Momo? Well, let me get the board back into my little setup here. I gotta watch out for this switch too, this little Raspberry Pi power switch. That's like the weirdest. You know, they make right angle switches that are not completely flimsy. I don't know what motivated them to use the flimsiest in the world, but they did. By God, they did, and they made it work, sort of. Jeez. It's just a completely floating switch. It's so weird. All right, power switch on Momo. Let me see here. Which one? On the top deck? Or this over here? So our battery, this is a big chunking battery. Holy shit. Battery's coming out and around, and then oh, I see. So that's what it is. So this pin here, and that's the one all the way on the end, and then the other one is is it the red? So these two on the ends go to That one goes to the switch. There's a bunch of wires coming out of this thing. Holy crick. Yeah, white wire from the battery. But then over here we've got red and yellow being switched together. Do those need to be connected when it's on? Oh boy. Crazy town. Yeah, okay, so it's just a power button. So that means red and yellow get connected together, and then red and white, or no, just white gets connected to battery power. And then ground is coming in through maybe black. I'm going to go look up the pinout. Let me just look up the pinout on GitHub. Yeah, so it looks like two of the lines on the Molex get switched together, and then power gets switched to the white wire, which is the one in the front. But I think it's probably better if we just look up the GitHub and get an actual pinout, right? Just so I don't hurt anything. Don't want to hurt it. Open mower. That's what I was looking for. Yep, that's the link from the PCB. Hardware. Sabo Universal Yard Force. Were we Universal? That's KiCad. No. Let's see. Schematic. README. EEPROM pins. Just commit, fix POM. Do they not have images of this stuff? Okay, 0.13 V1 yard force. Thank you. Oops. Yard force. So we are looking at connectors.sch, and it doesn't open in a schematic thing. The KiCad files also have it detailed. I don't have KiCad. I need another way to look at it then. This is all KiCad, huh? Here. Open mower yard force pinout. This isn't red. With a box around the thing. What is shifting over there? I think that's my water cooling in the stream computer, because I've got the window closed. It's getting cold in here, and it gets a little weird when the water cooling system is too cold. It has some troubles. It starts to make, like, it'll stop the motor and like make scraping noises and weird sounds, and it's doing that right now. Yeah, I'm looking for something that isn't married to KiCad so I can actually see this thing. I mean, I guess I could find like an SCH viewer and put it into that. And I think Fusion does do SCH files. I don't know if that's how universal that is, but I'm just hoping to get like a couple pinouts here so that I can identify, you know, how not to blow it up when I power it up. Yard Force. Welcome to the Yard Force, kid. Somebody's rebuild. Man, a lot of people doing this stuff, huh? These things look cool. Pretty neat. Like a 3D view of just the board? No, I just want like a pinout, like you would get on like for anything, like, you know, like do like motor controller pinout, you know, like that. That's all. It's just want that. I'm going to need one for the motor controller at some point soon. We haven't gotten to like the gathering information part of this, and I wanted to do like the low level. Let's take a look at what's, you know, what are the obvious things? What's the hardware stuff that's gone wrong first? Big John has been giving me all of the information, and I just have not been looking into it because we weren't doing the information gathering. So we're kind of getting into the information gathering stage here. And I don't know if I can totally robotically give you guys stages of how I go about repairing things. But the first thing is to look for the obvious, to take a look at the board, to clean up any weird soldering that might be there. And then second stage, power it up and make sure that we've got the right powers going on. We've got a lot of very sensitive digital electronics on this thing. They do not like to get the wrong voltages. So that damage that we perceived to the main 6 amp power supply going in was my biggest concern for powering it up. However, we saw that it was just dirt. I thought the thing had sheared off half of the chip. The whole chip's there. It was just a trick of the light. So now that we've taken a closer look, we cleaned up a little bit of soldering on, you know, one part of the board. We got a lot of flux out of there, about 1/4 pound of flux. But now we're looking at powering this thing up so that I can poke around and look at the voltages. I have no other information because I didn't research into this thing too much. If there was a big obvious problem, I might have been able to fix it and just kick it back at John, literally just drop kick it, go bam, and then ow, my foot, thing has a blade on it. And then that would be it. It would be off of all of our to-do lists with minimal effort. But now it seems like I'm going to have to get into that first layer of information, which is pinouts. I want to know what the sounded like I said penis in my mind right then. Anyway, pinouts. If I know the pinouts, then I can give it the power that it needs to function without blowing it up. That's my biggest concern right now. And it will partially boot up and start looking for network things that it won't be able to find. Right? It won't be able to actually communicate with the outside world. That's fine. At that point, I can look at the main voltages and make sure that they're okay to add stuff to. If my 5 volts is 5 volts, if my 3 volts is 3 volts, et cetera, et cetera. Once I've established that, we've got a good basis to look around at the digital signals. And we see if the digital signals are where they should be, so that if it's sending CAN bus communication to the motor controllers, I can look at that CAN signal and say, that's a good CAN signal. I can trust a new motor controller to go into this pinout without powering down most of the board or shorting something out. So that's where we are with this, right? God, I gotta do a round of cleaning up. I gotta clean up this this mug. I'm looking a little rough. So that's where we are right now. I just want to, for all the people that don't know, like repair and stuff like that, if you watch, what's his face, that British guy who seems like he's going to fly off the handle, that repair guy, he goes into it and is actually doing all these steps with the work, but I think he's omitting some of the sort of like planning of how to do it, because he always knows exactly what to go into and exactly what to do. And, you know, that's part of the whole scripted YouTube thing. We're unscripted here. You guys get to see the discombobulation of my thought train into something like this. From the most part, what I'm thinking right now with this, what's going to fix Momo is getting new motor controllers that are actually, they're in Big John's hands right now. I think maybe getting those in here and me make big adapter for this. So we'll drop some perforated prototyping board down on this, and I will get the pins that I need and the interface that I need to the stuff, because this doesn't quite look 0.1 inch spaced, and that kind of concerns me. So I'll try to make a good board that drops in here and then connects to the new motor controller board, which will take this, hopefully the same CAN bus commands, and then that'll give 40 amp motor controllers to Momo so that they're not spec'd to within an inch of their lives and they don't blow up again. I think that's going to be the solution for all of this. So what I want to do right now is figure out what those pins are, power them, and then we can start to probe around. But the introduction of that power switch means that there was something a little funky going on here. So instead of just having all the power on these pins and then having like a separate switch that'll actually just activate a MOSFET, which is the way I would have done it, there's two different switched things here. One of these gets 24 volts, and then the other one gets switched to itself. I want to figure out which ones are which on that, and I want something that's definitive, because again, I don't want to blow it up. We have an adapter where we can get into all the pins. I can cut this thing off, and then we can figure out how to connect this thing to turn it on. That, or I can plug it into its battery. I could do that. So the thing is, this is an open source project, and so everything is on GitHub. With everything on GitHub, it doesn't appear that I've been supplied with a simple image. And again, I'm looking for something like that for the pinout. I would appreciate that, but I don't think we get that. We get a lot of schematics and stuff. Do we get a PDF? For more details, let's try open more project. Okay, so that's the overview. Firmware, hardware, and we're Yard Force. And we're back where we started. I hate you, GitHub. I hate you. I hate you. I hate you. All right, Yard Force. The Yard Force SA series, that sounds terrible. And then Creative Commons at the end. Okay. I don't think I need the 3D files. Yeah, those are logos, Xcore lib, the YAML, SCH files, which I think I can open. Actually, SCH and PCB, I think I can open. What you got? Oh, Kindergarten Kid, how you been? Open this up. What do you got? What you got? What you got? Oh, this is the PDFs. Thank you. Very cool. Oh, I hate KiCad sometimes, man. KiCad. This is rough. All right, let's see here. So, of course, I want to get in here and actually zoom in. Yoink. File, connectors, KiCad. Oh, Jesus. Man, if I could send devs to a class on how to put together a good schematic. If I could teach them a class on how to make a good schematic, I would have a lot to say. Quite a lot to say, actually. Whew. Okay, it's not on that page. This is like the hardest schematic to follow. Power switches and connected. Power is always on. Switches are there for safety. And they do max of 1 amp. This is J16. This is U1. I could use a good class on how to put together good schematics. At some point when I'm doing, when I'm authoring a schematic, I usually go over all of the different criteria that I use in order to create a good looking schematic. Part of it is just the flow of everything, going from top left to lower right in your design. And then you try to build structures that engineers are used to looking at. So a lot of these like systems diagrams, I'm not a huge fan of. I know, using the bus bars in order to connect different signal flags are good for such a big digital project. You've got a lot of like multiple things connected to multiple things. So this is totally fine to do using your little pinouts, having your microcontroller on its own page and having all the branching connections going off of that. But if you're doing a lot of analog circuitry or simple circuitry, going from upper left to lower right, helps you follow the flow of the in to the out. And you know, all of these things are malleable. Every single thing that you would teach in a schematics class are completely malleable because there are no standards for this. It is just how do you communicate to another electrical engineer what's going on, what exactly is there. You know, if you put something in there that's theoretically in your circuit, you need to use a lot of dotted lines and a lot of text that tells you that this may or may not be the case, right? You're supposed to have a one-to-one representation of what's in there. Cutting stuff off like this, never. Why is there text that stops at the side? That's ridiculous. How do I use that? I need to be viewing it in the way that you view it, which is probably multiple pages at a time. So I don't know what's going on. There's a lot of stuff. This is fine. This is great because it's simple. Everything that I need to know is right here on the page. Upper left, lower right, kinda, it was close. Although, what the hell happened over here? And then we've got massive pinouts. That's unavoidable in a project like this. That one's why is that crossed out? Why is that why is that what's going on here? So can I actually drill down and figure out what the pinout of the connector is? So the connector is J2. See that in the corner over here? Right there, J2. I'm assuming that's J, because they do seem to be using good convention. Yeah, they are, J2. J's are usually connectors, so. Kind of reminds me of a better version of Tina. What, from Bob's Burgers? Who are we talking about? There's J1, there's J2. Hello, J2, how are you? P plus, battery voltage is always on. 2, battery ground. 3 gets switched on to 7 externally. Okay. Can I just hit in minus and in plus over here with 28 volts? The old schematic stuff from 2006 and older. Tina. We used a program called CirCAD, and it was apparently made by like one dude in Florida, which is insane to think, like, what is that dude's crew? That'd be so cool. I would hate to update software like that, but to have like, oh yeah, the FBI uses my CAD program to make their clean looking documents. That's kind of cool. So battery charge input, DV battery sense, and NTC bat. So if I might want to just plug in the battery and use it, because at this point, this is getting a little crazy. Which means we have to get all of Momo over here. Not all of Momo. Momo's head can stay over there. Although I might want to plug that in, but this just kind of complicates my bench testing. What time do we got? 3. Yeah, so I guess we're going to pull Momo over here and plug the battery back in and just get a full sense of it, since this is crazy. I could wire this up and I could make my own Molex connector for it, but then I don't have a temperature sensor to put into pin 8. So it could cause things to just go kind of haywire. So instead, we're going to test off of the battery and get the oscilloscope running from that. So let me clean like the whole bench off, because Momo barely kind of doesn't fit on the bench. See, that's off. Soldering iron's not off yet. I have a strong feeling that Momo is perfectly fine now. And our swap of the motor regulators are what's gonna fix everything. I still need to figure out how to get stuff off of these. These little duck bills hold on to the board really, really well. Like, this is really heavy, and I'm moving it by swishing the board to the side. So like, whatever soldering operations I do on this, I'm not moving it. It's not gonna move at all. So I think I fully endorse these things. They work quite well. And there's a different type of like pincher on the back of it too. So you can use the duck bill, or you can use the back piece to move it around, or to clamp things. And I saw them using these to like hold wires, so you could solder a wire onto something. So it was pretty cool. These were cheap, and they feel cheap, and that's not even tightened. Wait a minute. Hold on a minute. Now, if you ask me what they are, I couldn't tell you. You're gonna be on your own to find these. Nobody's paying me to endorse this product. I don't have a linky. I don't. Here, I can pull up the Amazon page. You guys can see it, but I'm not gonna go any further than just, saying they're good. Amazon.thong. Why is the period key not working on this keyboard? All the keyboards in the shop are breaking. My custom fixed one is dead. That has died. I'm calling it officially dead. And mostly it was me that killed it, because I tried to clean it off with alcohol, and the alcohol that I used was full of clear resin. And so I accidentally resin coated all of the filth onto my keyboard. Not good. Yeah, I know. Let me figure it out. It's magnetic helping hands is what they would be called. Here. But I think you have to be careful, because these, some of them are plastic. I saw some that were 3D printed, which would be bad, because if you're using hot air, you could, overheat this stuff. So these are magnetic helping hands. I didn't want to get them with the metal base, because I've got sheets of steel that I can use to, hold these things up. So. But these ones turned out to be pretty good. I mean, there's like 10,000 different versions of any of this stuff. I was looking around because I wanted something that would hold a circuit board a little better. Like, this thing was a rickety piece of plastic shit that I hated, and I eventually threw it out in anger, righteous anger. The little pincers on the helping hands, I don't know if I like them as much, because they can tend to scratch boards. Now, you can put a little piece of silicone rubber over the end of them, kind of like they've done with these things, and they're okay. But it wasn't until I saw these that I thought, you know what, that might actually be pretty useful, because if the magnet is strong enough, and you're not relying on these sort of crinkle arms in order to hold things still, it seems like they could be a good asset. So yeah, I think I endorse these. These seem to be pretty good. We'll see how they do on other projects. It seems like you also need to, like most things from China, you need to go over it with a screwdriver once you get it home, because that one was loose. And then the other part is the dismount. I don't know how I can make the dismount less painful on these. I hate those little grabby helping hands. What I use, you might be more familiar with, being the mechanical engineer who knows machining. Krigor and I got a bunch of stuff from some estate sales and some closing down machine shops, and in one of the drawers was a miniature Palmgren precision vise. Now, this isn't precision anymore. God only knows the precision between all these surfaces has been completely destroyed from its usage as an electrical engineering helping tool. But this thing has gotten me further than any of the other helping hands that because when I'm working on really small stuff, I want it to have a lot of inertia to it, so I can move the iron around and not have it slide. And then also, this is just heavy enough where I can swing it around under the microscope to see what I'm doing. Although I probably need to dip it in vinegar again to derust it. That thing is $600 new. Kind of funny you said you bought some of these AV to HDMI converters and had to go over every joint. I've never seen such bad solder joints. Yeah, I've never had something where I've had to go over the solder like that. No, these seem like I just need to tighten up the hex keys at the top. Hex screws. These are pretty good, though. If you got big sheet of steel, that gives you the inertia that I look for. And then 4 of these will grip the board pretty well. These will melt. But I have silicone rubber hose that I can put over the ends when the time comes. As for storing them, I have no idea what I'm going to do. But I wanted to give something novel a try, and they seem to be aight. And the magnets are properly sticky. Yeah, pretty cool. Well, duckbill holders approved. Okay, listen, as I said before, and I'll say it again. Anyway, no. As I've said before, I'm making myself laugh. Part of streaming is entertaining yourself. I said it before and I say it again. I don't want to draw out content on the stream. We have a pinout and it's crazy. I have to bring Momo back over here and get the brain plugged back into Momo and then do a little bit of voltage testing. And I feel like that would be better suited for tomorrow when we are actually, you know, completely stuck inside because of all the Canadian smoke that's in the air. It's about 4 o'clock, so we're about closing time. And it's an hour from closing time. I don't like ending early. I've been doing it a lot lately because I've been trying to structure what we're working on and have, you know, beginning, middle, end, and all that stuff. So for us, they look good. It's especially spring tension. Yeah. As long as your board isn't too heavy, and when you get 4 of these just barely pinching on something, it seems to be holding it really, really well. So I'm sold on these. You guys can try them. They're not too expensive. The ones that I've been using were Control-Shift-T. $15, little man, for a pair. Put that shit in my hand. If you don't got the dough, then you owe me, oh. Oh. Jungle Love. You know, for the fact that I know that whole part, and I've seen the movie like once. I've seen it like once. I didn't watch it again at some point. Anyway, every time the number 15 comes up, I am unfortunately contractually obliged to go through that whole scene. I don't know why. It's just me and a friend always did that. Anyway, my aunt always sings that, and she's only seen it once as well. It's a good Kevin Smith. Get back to that kind of writing, man. You write good sometimes. All right. Yeah, I don't like to draw it out and do more than I should. And we've gotten Momo to the point where I am trusting that all of the concerns about powering it up and stuff are not really. I don't know, man. The concerns are ill spent. No, that's the wrong. That's like, I don't know how to communicate in the English language anymore, chat. I think I've lost the ability. It was catchy. Yeah, it was catchy and memorable scene. You're right. God, this is the worst. This switch right here is the worst. It's probably fine. It's probably fine. I feel like the power supplies in here are working. From the description from my friend, if I plug in the GPS, things are okay. If the motor controller board plugs back in, things are very not okay. So we'll wait to plug these in, and I'll wait to plug the GPS in just to be nice. This thing apparently will power up as it is right now. That means that our voltage regulator is perfectly fine. That means that I can test the outputs over here, and then I can test power going to the Pi. I can test power going to the other Pi, the Pico Pi, and then I can look at the digital lines out here and figure out what they're doing. And if those voltages look okay, the supply voltages for the motor controller, the control pins for the motor controller, those look okay, I would go ahead and build a couple breakout boards of these 3 so that we can plug in the other motor controllers, and this thing can have stronger motor controllers. And then we can bring the GPS back in, and I'll leave it to my friend to do all of the, you know, tuning and stuff that it may or may not need. It may not need any tuning. I don't know what the commands are on CAN bus, so. But I think that's where we're gonna head with this. So for now, I'm putting this back on the shelf. Tomorrow, we're gonna get everything over here onto the bench, and we'll go through that testing. We'll go through powering up the board. I wanted to put it on my own power supply so that I could gradually power it up. It looks like a 3B plus is what we're actually. That's not a 3B plus, is it? Is it a 4? How do we tell from the bottom? 94V0, 2.1. Uses technology, license from, yeah, blah, blah, blah. Kind of looks like, but 4, I thought I had a big, where's my Raspberry Pi? I have a pretty powerful Raspberry Pi to pick. Where did it go? I think it's on the shelf over there. Here it is. This is the 4. What did I just step on? Oh. It's something 3D printed that I was just on the floor that I stepped on. Okay, it's not a 4. I think it's 3B plus. Wait. Maybe it's a 4. Oh, no. No, it's not. No, it's not. Blue USB 3 suggests it's at least a 4. How is... Mine's a 4. Why is... What the... What the hell? No, I see a Raspberry Pi logo in there. I'm not good at identifying these things. I'm not as familiar with Raspberry Pis. Generally, all of the projects that I work on, a Raspberry Pi is like way overkill. So you don't need a whole computer. Doing robotics and stuff, I guess the Raspberry Pi is probably pretty awesome in terms of like, you can use like Robot OS and stuff like that on it. But I generally like Burn the Subs was the most Raspberry Pi worthy project that I've done in a while. And that even still, I probably could put an RP2040 in there doing MicroPython to do all of the different database calculations and stuff. I don't know. What do you guys think it is? Oh, wait, there's our answer. It's a 4. 4 something? Model. I can't see it. I can't see it. Wait, the Pi 4 was 2018? What have they been doing over there? Oh, that's right. Mine's a 5. So Pi 4 Model B. That's right. This is a 5. It's got that big ass Broadcom on it, and it's collecting dust. It's collecting dust as any Raspberry Pi 5 does, because nobody needs this much computing power. I guess we got... Wait, if I move the jumper, do I get more memory? Oh, this is the secret, isn't it? I could buy Raspberry Pis with 1 gig and move the jumper and then sell them for the 8 gig price. Oh, we've got an ad break coming up. I was going to end right before an ad break. I guess I'm going to wait a little bit. Yeah, I've got this Pi 5. I don't know what to do with it. It's too powerful. It's like a whole ass computer. Like I could probably play Minecraft on this thing and it wouldn't break a sweat. What the hell kind of a test is that these days, bother? Minecraft works on like a Game Boy. It's got a button on the side. I didn't know that. Ah, jeez. It's like a button on the side and a switch and stuff. And then you go to like somebody else's GitHub project and you get this flimsy thing that's threatening to break all the time. I could even today get a different switch in this thing. What I really need to do is drop a little dollop of UV epoxy on the back end of this thing. Because UV epoxy will come up clean from a circuit board and it'll brace this thing a little bit better. But I don't want to take my glues out right now. 8 gig is like $200 now. I got this one for like 70, which was still a lot. But for me, for my projects, you know, we never need the Pi. It might come up if I want to use like, I was thinking of hooking this up to 2 monitors and having like a chat computer for Julian and anybody else who I have as guest, have a little chat computer. I think I want to hook this up to that monochrome green screen. So I need to figure out how to adapt the super crazy HDMI here. And I thought these things would go down in price, but now this thing is worth its weight in myrrh. So what do I do with it? Yeah, I make a cyber deck. That's nuts. Boy, oh boy, Sam Altman. I love AI. Please don't crush me under your heel. But at the same time, do I have choice words for that? God damn. You got all the fun tools. I bought this because it was like, it just came out and the price was cheap. And I guess I lucked out. I did exactly what I was setting out to do. And that's get in on it while it was still like affordable and you know, scaled to sort of my resources. But now that I have it, what I do with it, right? What am I going to do with this? Gonad is doing a very interesting project. Love the projects that Flatulent Gonad works on. He does, you know, that right amount of British whimsy in the projects, and he's making a miniature PC that has a Raspberry Pi in it. He's got a couple already, but he's making sort of the latest iteration of that with like a nicer screen and everything. You can put chat on it. It's a beautiful little project. I love it. For me though, most of the stuff that I do is little microcontroller stuff, right? Or analog synthesizer stuff, or making stupid shit light up in my shop when a channel raids. This looks like I was up to something no good. Let's get all these paper towels out of here. Yeah, we're gonna get Momo back on the bench next time, and we'll get it to spool up and do everything. But what I'm saying right now, just during that little ad break, it still says starting soon. What's going on here? I'm just talking about the Raspberry Pi 5 and how it doesn't really apply to the stuff that we do here. By the way, these are flickering. Let's look at these. Actually, let's look at this real quick. It's just the end of stream, right? At the end of stream, we're going to look at some of these flickering light bulbs and see if we can figure out why they F. Why do you F? Momo identifies as Momo. That is very Momo-brained of Momo. I would expect no less from Momo. Thank you for you speak for Momo. There's some solder on like the side of this connector. Jeez. Okay, yeah, let's get this back over to Momo so Momo has Momo's brain. Because Momo's brain is very important to Momo, I assume. Momo's going, well, thank you for bringing back my brain. I really appreciate it. Yeehaw. All right, I gotta watch power wires here. And I can just get this. I'm gonna loosely put this back, but then we'll go back in and make sure everything's nice and neat and clean before I actually screw it down. We won't do too much altering of, you know, where stuff is and how stuff is attached. I want to leave Momo as Momo, you know? A long time ago, Julian got me this, not got me, he brought in for me to repair this synthesizer-y thing. I forget what it was called at the time, but it had a lot of switches and buttons on the front panel, and I totally rewired all the switches and buttons for him. And then I realized when I gave it back to him and he went, well, now it's not mine anymore. This is now something that you've built. I was like, oh, maybe I shouldn't totally redo stuff that comes into the shop in my own image. Deck Momo out with some cold cathodes. Man, remember cold cathodes? Had a nice little 1400 volt power supply in your computer. I'm sure that didn't introduce interference into components that don't really like interference. All right, Momo parts, keeping right there. Any more Momo over here? Yeah, these two screws. Need to keep these two screws for Momo so that we can put all that back together, and then we'll probe around voltages tomorrow. But for now, I want to take apart one of these light bulbs. So these are Philips warm, what is it? Hold on, let's take a look. The model and everything. These are failed light bulbs. And we can move this holder. These were the kitchen lights for the drop lights in the kitchen. And UL listed. Mother approved. That's all that. 2700K. 27? That seems a little weird. 60 hertz. Eco Smart. Don't open it up. Suitable for damp locations. Risk of electric shock. They're suitable for damp locations because everything is ultrasonically welded together these days. So this is an LED, I believe it's Philips. Whoever does EcoSmart. 111 milliamp, 2700K, 8 watt, 120 volt. So these are just drop-ins that work with faders. These were in the kitchen, and it turns out eventually in the kitchen we had flickering lights. So you wouldn't really be able to tell, but it was solid light, and then it would suddenly very quickly just flicker out. Now one of these is dead. One of them is just flickery. I want to take a look at these because every time we've taken a look at something like this, there's been something particularly cursed about the actual bulb or the driver or something of that nature. Now the last time we took one apart, I had my Nipex. Ooh, I just hit that pretty hard. I had my Nipex sitting here, so I would like to find my wrench. I don't know what I did with it. What was the last thing I did with the Nipex? I don't want to like hurt my hands taking this thing apart. The little channel locks helped me get a grip on the back here, because these are a lot like the Tasmoto light bulbs, where it's just kind of like pushed down and then crimped. So we can get this part out and then we can remove that part. But to do that, I would like to have a better grip so I can twist it a little bit, and that'll kind of loosen that. But if I can't, I can't. And I don't see the Nipex anywhere, so that's really vexing me when, you know, when you have a tool and you know where it is and then it, poof, vanishes suddenly in the dead of night. I probably put it on a pile, and so it's probably still on that pile somewhere. The SKU pulled up EcoSmart as the brand. Oh, okay. So maybe they're not Philips. Maybe they're not that reliable. These get a pretty good grip on wide things, so maybe I can make those work. Nipex wouldn't have slipped like that. That's like insets, so that's not like the Tasmoto bulbs. That seems like that is not... On the Tasmoto ones, you can actually get under that and peel it straight out. But this one kind of goes into the plastic a little bit. So that might actually not be as removable as I thought. Let's try the whole thing. I'll just... Whoa. Okay. Well, now we know. It is, in fact, a button. And there is a wire going to the button. And then a wire that folds in with the connector when it... Nope, not going to happen. Yeah, these don't like to give up the ghost. So if I was trying to actually get this to survive, I could probably work at the edge of this here, or try to... the spinning thing didn't really work because of the weakness of the metal. Because of the weakness of the flesh. Man, Warhammer is everywhere, isn't it? I have blocked so many subreddits that are Warhammer related, and I'm still finding them. They're still showing up. Although I guess they disabled the all section. Okay, so typically what I would do now in order to get the lens off, since this is plastic welded together, it's pretty permanently connected. Removing one of these things from the other is just going to break the plastic. And the way that I would do that is by putting it in the vise. So I have a controlled pressure on the outside, and I can sneak up the pressure until it cracks the outside here without sending sharp plastic near my fleshy hands. The vise is in use right now, holding things up a little bit. Maybe we could open that up and I can actually get in there. My other two vices are either too small or being used right now. So maybe we do just open this thing up. I got to get all this pick and place items off of here. And then there's a cord right there that's right in the way. Okay, maybe we can do this. Don't dump it all on the floor. That would have dumped on the floor. These are a bunch of motor controllers that I ordered for the simulator setup, so that I can move the steering wheel around using buttons. And then later CAN bus. Right now, I need it to pinch my light bulb so we can see what killed it. Or who. Well, let's not send jagged metal into my hand again today. Yep, see, this is... Oh, yeah, did that draw blood? No, okay. I've got all the jagged metal on the other end here, and I gotta be careful that this thing doesn't angle the bulb and hit me with jagged metal. All right, there we go. We do this until we hear a big popping noise. There we go, big popping noise. I like it when you call me big pop, big noise. Who is this streamer? Dunno. I'll let you know when I know. All right, so let's see what makes this thing tick. How complicated these light bulbs are. Looks like there's actually an RTV silicon sealant on the lens, so it actually could have been pretty easy to remove without using the vise. I just use the vise because it bends everything. Yeah, this is the one that I marked F for flickers. Not dead, flicker. So this pulls out, and it's probably against a bunch of silicon. So if I can get a long... I made a mess for myself by making this into a finger cutting machine. do not the light bulb. But just like the other ones we saw, this is probably held in with a bunch of shmoo all the way around the outside just to get the heat out and away from your LED driver. There's a little edge here that I can kind of pry up on, but I don't know if that's doing anything. There's a nice full bridge on this thing. I see it. Oh, no. Yeah, big old full bridge on this. I feel like stealing parts from a failed light bulb. I don't know. There we go. So get this as far away from me as possible. It's always the capacitor. We've seen burnt up traces on these, which I find really concerning. That's why I wanted to pull these apart. That's why I put these aside, is because these are just flickering. They're not dead. But on one of the dead ones of these, we saw a burnt trace, which does not fill me with confidence, because a burnt trace is close to a burnt house. So yeah, first thing you always look at, the cap. It's in like a connector? Do they fail so regular? Why would you have it? Wait a minute. Why would you have it in a connector? What? Maybe so they could, no, but in the lifetime of this light bulb, first of all the stuff that you just saw with me peeling this thing apart, absolutely not user serviceable. That's negative user serviceability. Why do we have a reusable plug? I'm going to keep that. I want that plug. And then, of course, your power in, those are a one-time use. I would expect those to be like what's connecting the capacitor. Isn't that crazy? This is why we do this, chat. Is it bulgy-wulgy? No, it's not bulging. Looks at your bulge. Yeah, no, it's fine. Stares at your bulge a little too long. Yeah, it's pretty good. Yeah, those I can't remove. Yeah, it's not going anywhere. It's a pretty good little connector thing for a one-time use. I've never seen that capacitor contact. It's not specifically for capacitors. It's for like just general. We've seen them in the what do you call it? The Casmodized ones, the RGB ones. We've seen connectors like that. Very, very similar. Of course, you got your LED controller. You got your full bridge rectifier with a singular diode on it. And then your train of LEDs. None of them look particularly stressed out, though. So why were the lights flickering? Yeah, it would just be a connector for pins. And then they shoved a capacitor in there, which does not have the same spacing. And somehow none of them wiggle their way out in transit or in usage. Oh, because it's pretty far in there. This might actually lock it in. That's very strange. I've never seen that before. Oh, you know what it is? I know what it is. It's the cap. What is that, like Joe Rogan when he sees Batman? It's the bat. Joe Rogan looks like a thug in a Arkham Asylum. They wanted to have the cap under the board. Under the board is conductive. And so if they had just pins going through the board, then it could have bent to the side, vibration and whatnot, road noise, vibration, and harshness, and then contacted this. So they put a connector on there that locks the pins in place, and it insulates down here so that if the cap bends over, it's not gonna contact. Yeah, it's just a lot to go through. It's, a whole part for that, dedicated to that. That's fascinating. And then we've got some kind of like a load resistor sitting here that is out in the open, and everything looks totally fine. Why was this flickering? I don't know. That one was flickering. I think the other one was dead. Interesting. All right, well, no conclusions there. I was hoping we would find something as definitive as the burnt up, broken... Wait a minute. That I might have done while I was removing it. Yeah, that's me. I did that. That was on me. The ICs are fried. No evidence of that. Could be. That could be. Can't rule that out, although I think these are probably pretty simplistic voltage regulators. Probably surplus, yeah, because we did see connectors like this in the RGB ones that have like a whole ESP in them. Yeah, and this is, again, I've never seen this before either. It's crazy. But yeah, I guess if you've got like a factory or a warehouse full of these things, then it might be cheaper to use those. Version 2.0. I'm just looking to see if there's like a cracked trace or anything, and I don't see any evidence of that whatsoever. I'm sort of shining the light on the on the solder mask to try to see if I can see any disturbance beneath. But there really is no evidence of anything going afoul. It's a simple looking board. It looks like they used sort of a goldish kind of solder, I guess to keep corrosion away or something. Never seen a resistor soldered like this? That's a big old resistor, I don't know. Big old school through-hole resistor on here. Whereas it's probably supposed to get a big surface mount one, but they must have, the margins between the two, maybe one was cheaper one day than the other. What's all this here? I don't think that's a disconnect, is it? Get closer. I can't get that much closer quickly. It's making contact. This looks a little worn, but not really. There's a little oxidation around it. Well, it's the sort of the framing. They're not using a silk screen. They're using the lack of solder mask. And so with the lack of solder mask, this still gets whatever that gold wash is that it gets afterwards, but there seems to be like a little weird corrosion around this area. I don't think that's what eventually caused the flickering, though. To be honest, I don't know. Let's open up the other one. We'll open up the other one, and then you guys can go home. You can finally leave. I think I have to do the jagged metal thing on this one, because if I just break the front off, these little like pincers will not let go of the wires. So the only way to get it to let go of the wires is to manipulate the back end. Nope, there we go again. Whoa, wait, there's electronics right here. This one's just built different. Okay, well, I gotta be careful of jagged metal, but yeah, there's a seam back further. It could be down to the socket that connects the bulbs, you're right. All right, so the big fear here is that this kicks it to the side and into my hand, where my flesh is torn from my skeleton. Jeez. That one went out with a dramatic pop. That was kind of loud too, so I'm gonna get like, what were you doing down there? Once I had a TV's backlight, give up the ghost, opened it up super careful with all the panels, and a big black stain around an LED. Wait, super careful, all the panels and all the big black stain around an LED. Bridged it because I didn't have it, and it fixed the backlight. It basically failed open. Whoa, so like the backlighting failed, and then you just bridged it, and it was, whoa, this is a different design. Oh, back up a little bit. Back it up. Oh my God! Don't stare into light with other eyes. So yeah, this is the driver. It's got all the LEDs just sitting right there, hanging out, 6 feet apart on a PCB. Why was that so bright? Oh, it was reflecting all the light from up there. Okay, let's take this apart a little bit more. Yeah, the same capacity. Well, it's thinner, but it is the same style connector. You're right. Now I got to be careful because this will cut my hand very easily. I had a stream one time, and right before I started, I was going to do working on a fume hood for my brewing setup. And right before the stream started, I cut a piece of duct, and it just went fwink and put just this huge gash on my hand. I had to tape it back shut and stop the bleeding, tape it shut. I still was able to stream on time, but I had like a giant paper towel attached to my hand. Was that something loosening up? No. Oh, it's a giant metal substrate. That's right. I kind of remember these. These are not designed to come apart. I need to like break the plastic basically to get in there. So I'm breaking the metal too. These are not built expensively. Jeez Louise. Okay, we gotta get this one out. Light bulb surgery is always kind of fun because these things, first of all, they have no value. No value, no lessons to teach us, nothing. We can just get in here, take it apart, see if it gives us any outward signs of damage. Yeah, they're built to be disposed of, yep. Just like me. Jeez. I mean, just like in a glass light bulb, you don't want to get in a light bulb fight. A lot of connections are plastic welded. These just drop out. What? I've had some great ideas with some lights. The light lighting up because you just lit up the idea light. Open them up, get disappointed, leave. Story of my life. You open up, and they get scared, and they leave. Here we go. So this one has an older driver, and it's a big old regulation board with a transformer and everything. That's one light, and this is the other entire light. So something gave, and they said, well, we could just make this power from 120 volts if you just put a full bridge rectifier in there. You don't need a whole huge power supply if you just use our chip that'll do all that work for you. How cool is that? Do you suppose the LEDs themselves are good? It may be an LED failing in a way that we can't see that makes it flicker. That could be. Now this is held on with RTV, so I don't know if I can get it off of there. We have done in the past, we have been able to get these things off of there, but I don't want to cut my hand on the jagged edges over here. This hurts a lot. There's a lot of jagged edges that I created just by moving this around the side. RTV is like a silicon, yeah. It's like a plasticized silicon rubber kind of thing that resists voltages. It's very insulating and it holds stuff together. It has a high temperature coefficient and all that. Celastic, people call it. Question, how long have you had a light for? I don't know. People bring up the argument the use of them is cheaper in the long run, but I've not seen it last for a full year. We've had some troubles with those lights going out, and I think it's because there's a hallway above it where people are stomping back and forth. Yeah, have they lasted a full year? I think so. Some of them have, definitely. And the promise of the LED itself was that the good LEDs, not necessarily the ones that we're using here, are very long lasting, like thousands and thousands of hours. But have we seen that performance? Not necessarily. I hold on to these because they've got this nice little full bridge rectifier on them. And that full bridge rectifier is useful for me actually when you build synthesizer circuits, because you can put the full bridge rectifier on it and then your musician buddies can plug in the power plug in either orientation. It doesn't matter which way they plug it in. So this is a lot of electronics. It's got a lot of interesting electronics. What it does not have is a giant 10K resistor, sadly. Although we put the 10K on Momo, so that's I think I'm done with that. I don't have to think about that one anymore. There's a big 390 that I needed that for a different circuit at one point. All right, so nothing looks outwardly explodey on this. It seems to be relatively simple. We've got a full bridge rectifier. We have a bunch of safety caps. We got our big smoothing cap for after the full bridge. And then we have a transformer for some reason, probably to kick down the voltage to a certain level. So we're probably bucking through that, although there is no there's only a transistor over here. Got 2 transistors on the board, so that's interesting. 4520, I don't really know what that one's doing. That's probably what's doing the bucking, huh? Something like that. We got more transistors. Yeah, we got all kinds of stuff. But none of it looks like it blew up. Big load resistor. Got a metal oxide varistor, which is just for surge protection. Which is, by the way, I mean, surge protection, we've had a lot of power outs this year. But apparently that's okay. Oh, there's like a load resistor on this? What the hell? Weird. Nothing blown up though. As far as the LED board is concerned, we have another one of those very similar connectors, but not quite the same thing. But I would assume that any given warehouse is full of all kinds of iterations of this if you're manufacturing tons of light bulbs. None of the driver chips are showing any sign of fatigue. I fear that I have taken apart 2 perfectly functional, that's from 2015. Look at that, 824, 2015. Good vintage. That's a little damage there, but I might have done that. That might have been me noodling around with it. Yeah, that was me, I did that. Although this, wow, that really gave up the ghost pretty quickly, huh? Brittle plastic from heat cycling, I guess. Those rectifiers are like $1 now, and AliExpress double dips on the taxes too. Ugh. Well, I don't really order from AliExpress that much. I'm more of a DigiKey kind of person for stuff like electronics parts. But anyway, it's always good to have... Ow, what the hell is that? I just got like a splinter of plastic. Ugh. These things suck. Did I get it? I hate getting splinters in this part of your hand because it's so occasional that you brush up against it. And even like a microscopic little splinter you'll feel it. Happily you're from DigiKey, but they don't try. Oh, you're in, yeah. You guys have a tough ordering situation over there. I don't know what to recommend. Yeah, here in America, we've got like our DigiKeys and, you know, local warehouses for stuff. But all right, anyway, done with lights, done with stream for today. We're gonna come back tomorrow. We're gonna do a little voltage testing on Momo. We're gonna see if Momo's brain is speaking brain to its own brain, and then we're gonna think about pinouts and motor controllers for the Momo upgrade. Momo's gonna get a 40 amp controller for each motor. The spinny motor and the spinny motor and then the spinny motor. And then the 2 motors can spinny while it spinnies. I'm out of here. I'm back tomorrow. Tomorrow's Friday. We're going to get into it a little bit more, work on some cool stuff. Didn't program the end card because I forgot. I could do it now. I could maybe take a look at it. Hold on. Where's Oh, is Sark on right now? Oh wait, hold on. We gotta make sure who's online right now. Doug is doing Mecha Chameleon. I'm waiting for Doug to do like a real serious software project because he does a lot of like weird fun ones and has like a ton of viewers to raid you guys into. But for now, what was up with the lawnmower? Motor controllers is the MOSFETs. They got a heat sink, and the heat sink caused shorts, and the shorts caused blow up. So so we're looking at the rest of Momo to see if anything was damaged. We took a look at the board. We cleaned up a little bit of soldering, just stuff that I wouldn't let leave my shop because it's a little risky to have like a surface or a through-hole resistor just dangling off of the side of a I don't know, MOSFET or something like that. So we fixed up the soldering a little bit. We made sure that things were seated properly and took a look at a bunch of the other chips, and everything looks good. So now is the stage where I plug Momo back into its own battery, and we see whether or not the voltages of the board are good. And if they're good, we're going to get some 40 amp controllers. Friend already has them, and adapt them over to Momo. Now, I could send you to paleontologizing, doing a little IRL. It seems like there's a bunch of people online, but nothing that I think I really want to raid you guys into. Polrin is on doing software, but so what I'm going to do, I'm going to close down, and I will be back tomorrow. I'll do my, hold on, I'll do my admin card live on the air. Do my little administrator thing. Oh, I see how it was done. Yeah, so we did exactly the same thing. This is how it was before, by the way. I got sent a picture that I missed. It was directly from Q5 over to D2. And, oh, so that's different than what we wired up. I gotta go fix that. So I'm gonna leave this up. We're gonna fix this first thing tomorrow. I'll desolder it before I move on. Because that's what we have now is wrong. It's supposed to go between these two, which is a little strange. I guess it's directly from that leg. So what I can do is I can get a little wire wrap wire and I can run it up the side of this so that we have that connection. That's an interesting and weird, because that is technically connected. So, I mean, it was a good bodge. It was done out in the field, like literally in a field of grass, you know, during a hot time of year, using a portable hot air gun. So like, you know, what do you expect? That's a good fix. Laying down the 10K resistor on the board probably would have been better, but what I can do is I'm going to put the surface mount jawbow like to the side, maybe down here, and just use a little piece of wire to connect it up there. And that'll make it good, and then when things start vibrating, it won't get displaced. So anyway, so I'm going to do the end card real quick. Go to my admin. There's just a picture of Momo in the admin section. Yeah, that's a weird little fix. I guess it's, what does it do? Apparently it fixes inrush. So let's do, today is not July 14th. What the hell? 16, so tomorrow's 17. And then I can do this. Okay, so I'll do that solder fix in the next couple hours and make sure that that's good to go. And then tomorrow we're going to look at voltages. We'll turn it on, turn Momo on, start probing around and take a look at what's chuchin, what's digitally communicating, and if they're in specification. We're still not at a point where we can do any of the more complicated things. I don't want to. I want to do all the very simple stuff and make sure that the foundation is there so that when we put the new motor controllers in, they don't go, and then die. So I will see you guys tomorrow. Thank you for joining me. We will be back, and you got approximately 20 hours without me to survive. That was supposed to be where the next screen comes in, but I keep fumbling it because I don't know to just hit the button.